Hi students, so today I am going to discuss the entrance test 3 of Eklavya. I am going to discuss the physics paper. Let's start. So the first question says that consider two infinite large parallel current carrying sheet. Current per unit width in both sheet is given as 2 by root pi ampere per meter. Okay, if the direction of current in both sheet is same, then force per unit area on the sheet will be. Now let me first explain the situation to you. So the situation is like this, this is one sheet, let's say this is a sheet, and parallel to it there is another sheet. Okay, and both are carrying current, they are carrying the same current, they are carrying current per unit width in both sheet is 2 by root pi. Alright, the direction of current in both is same. So both are carrying current like this maybe. So this is carrying current in the upward direction. Okay, so throughout this sheet the current is flowing in the upward direction like this. Okay, so this is what is there, and we have been given the value of current per unit length, okay, which we represent as K. Usually this is represented by the K symbol. So K is the current per unit length of these sheets. Now one such sheet, alright, if we ignore the presence of second sheet for now, presence of second sheet for now, and if I talk about the magnetic field produced by one sheet, alright, so this sheet is carrying an upward current, so on the points in front of it, it will create a magnetic field in the inward direction. Alright, it will create a magnetic field like this, okay, horizontal magnetic field like this. Okay, and on that side the field lines will be opposite to what we get in this side. Alright, so if we have a look, side look in this situation, if we are looking from the side, okay, so the situation will appear to us like this, this is one sheet, okay, this is one sheet in which the current is flowing in the upward direction, and the value of current is K ampere per meter. The value of K is given to us. Okay, because of this sheet, towards the front of the sheet, the magnetic field that we will get will be in the form of crosses. Okay, in this region the magnetic field that we will get, it will be in the form of crosses, and the magnetic field that we will get on the other side, it will be in the form of dots. Okay, it will be in the form of dots. Okay, now understand this, if there is a sheet, another sheet kept in front of this sheet somewhere here, okay, and this sheet is also carrying current in the upward direction, okay, then what is happening, like there is an upward current, there is an inward magnetic field. All right, so all the elements, all the the wires that are constituting this sheet, we can assume that this sheet is made up of a collection of infinite wires, like one wire adjacent to it is another wire, adjacent to it is another wire, adjacent to it is another wire, and so on. All right, so all of these wires will experience a force in this direction. We want to know the force per unit area. That is what we are seeking. We are seeking the force per unit width, force per unit area. All right, let's try to understand this question. So for that, let me again draw the sheet. All right, so if I draw the second sheet somewhat like this, we want to know the force on unit area. So I will select, let's say, an area of length 1 meter and 1 meter here. Okay, and I would want to know how much force is acting on this area. So let's try to understand this, that the total current, okay, which is passing through this area, all right, this current, all right, that would be K into 1, because we are considering this length as 1. So K into 1 is the total current in this strip of width 1. Okay, and this will experience a force in this direction. It will experience a force in this direction. This force will be given by what? This force will be given by B, I, and then L, the length of these wires. So the length of these wires is also 1. Alright, so B, I, 1. Alright, I is this, K into 1. So this will become B into K. Since I am already calculating the force on unit area, whatever force I get, that is the answer. Alright, like I am calculating force, but I have considered the dimensions as 1 meter square. So whatever I get from here, that is the answer. Now, how much is the magnetic field produced by a infinite sheet? So that magnetic field is given by mu naught K by 2. So this is B, this is K. Okay, so this product will give me the answer. So this is going to be our answer. So let me write this as mu naught. How much? What is the value of mu naught? So mu naught is 4 pi into 10 raised to power minus 7. Okay, that is mu naught divided by 2 and then k square. The value of k square will become 4 upon pi. Okay, so the pi gets cancelled and this becomes 16 by 2, 8 into 10 raised to power minus 7. So we are looking as option B at option B as the answer. So option B is the correct answer here. Alright, so that was question number 1 for you. I hope you understood the entire situation and you understood the solution as well. We'll now go to question number 2. Okay, so let's see what question number 2 has in store for us. So it says consider two uniformly charged concentric and coaxial rings of radius 3r and 4r. Total charge on the inner ring is q1 and on the outer ring is q2. Both the rings are revolving in the same sense with same angular velocity about their axis. The net magnetic induction at the distance 4r from the center of the ring on the axis of the ring is 0 then. Alright, so I'll explain the situation to you. So the situation is somewhat like this. We have one ring of radius 3r, alright, and then another concentric and coaxial ring. So concentric and coaxial would mean a ring like this. Alright, so this has a radius of 4r and this has a radius of 3r. Alright, so 4r, 3r, they are the radii and they have charge q1 and q2. So this one has charge q1 and this one has charge q2. Okay, this is the axis. And now they are both rotating in the same sense with the same angular velocity. So if this is rotating with omega, then this is also rotating with omega. So their rotation will create situation as if there is a current in a loop. Like this ring will start acting like a current carrying loop because of the rotation of the ring. The other ring will also start acting like a loop. Alright, and both these current carrying loop will produce magnetic field in the surrounding including the axis. Alright, and the question says that at a distance 4r from the center, the net magnetic field is 0. Okay, then what is the ratio of q1 to q2? So let's try to attempt this question. So the key idea here is that this rotating ring will produce a current which is given by q1 into omega by 2 pi. Alright, similarly I2, the current in the second loop, that will be given by q2 into omega upon 2 pi. So these are the currents. And now how do we write the magnetic field on the axis of a current carrying circular loop? The formula for that, let me write the formula for that first. So if there is a ring carrying a current I, then how do we write magnetic field at a distance x from its center if the radius is r? How do we write this magnetic field? So the formula is, the standard formula that we are going to make use of. This formula is mu naught I r square upon 2 and then x square plus r square raised to power 3 by 2. Alright, and there are multiple terms, then we also multiply with the number of terms, which in this particular case is not there. So this is the formula that I am going to use. So I have two rings, I know the current in each, and they are both producing a magnetic field at some point, and the net value is coming out to be 0. So let's do the math now. Okay, so let's do the math. So guys, I will write mu naught, then I1, the radius of the first ring was 3r, so mu naught I1 r square upon 2, then r square plus x square, x will become 4r, that was given in the question. Okay, and this entire thing raised to power 3 by 2. Okay, plus the contribution from the second ring would be mu naught I2 4r square, okay, divided by 2 times, then 3, not 3, it will be 4r square plus 4r square, and this entire thing raised to power 3 by 2 is equals to 0. So this is what we have to solve. So let me take out the common quantities, like things that will come out as common, and then they will take it on the other side, so they will disappear. So what are those quantities? Mu naught will disappear, okay, 2 will disappear from both terms, r will disappear from both terms. In fact, this r can be taken out of denominator, alright, and it will ultimately disappear, alright. And I1 can be replaced as q1 omega by 2 pi. The omega by 2 pi can also be taken out. Here also Q2 omega by 2 pi can be taken out. In other words, we can replace I1 and I2 by Q1 and Q2 because we are looking for the ratio of Q1 and Q2. So let me do this. Okay, so I am writing it as Q1. I hope this green color is visible. Yeah, and Q2. So I1, I2 have been replaced by. So is I1 equal to Q1? No, that is not the case. What I am saying is that I1 will be written as Q1 omega by 2 pi. Omega by 2 pi can be taken out as the common quantity. From here also it will be taken out as the common quantity, and then we take it on the other side, it disappears. So ultimately now what we have to, when we go to the next step, this becomes 9Q1 divided by 3 square plus 4 square. 9 plus 16, 25. 25 raised to power 3 by 2 is 5 cube. 5 cube is 125. Okay, so this is what we are getting from the first term. Then from here what are we getting? 16 Q2. 16 Q2 divided by 16 plus 16 is 32. 32 raised to power 3 by 2. So 32 raised to power 3 by 2. Okay, so 32 can be written as 2 raised to power 5. 2 raised to power 5 into 3 by 2. That's 2 raised to power 7.5. So 2 raised to power 7.5 is we are getting. In fact, we can adjust this 16 also. So 16 is 2 raised to power 4. So I'll subtract 4 from here and I'll get rid of this 16. Okay, I'll get rid of this 16. So this equal to 0 is what we are getting. This equal to 0. We want to know the ratio of Q1 by Q2. So when we do this, we take it on this side and then we do the calculation. Q1 by Q2 will become 125. Of course, the negative sign will be there. Divided by 9. 125 divided by 9 into 1 upon, and this is how much? This is 2 raised to power 3.5. So 2 cube into root 2. 8 root 2. So this is 8 root 2. So we are looking at minus 125 divided by 72 root 2. Let's see if we have such an option or not. Minus 125 by 72 root 2. Do we have an option like this? Minus 125 by 72 root 2. Option A is there. So that option will be your correct answer. So the correct answer to question number 2 would be option A. Okay. So that is your second question. Alright, so this is your question number 3 now. So in question number 3, it says that a conductor of length L has the shape of a semi-cylinder of radius R, which is much smaller than the length L of the semi-cylinder. Cross section of the conductor is shown in the figure. Thickness of the conductor is T. Alright, conductivity is given to us and we want to find out the current. So let me explain the question to you, everyone. So the object given to us is in the form of a half cylinder. So something like this. Alright, it is in the form of a half cylinder. Okay, and it has got some width also. So the figure should appear like this. Okay, this is the situation. Okay, now in this figure also the conductivity varies with theta, which basically means that if I divide this into strips like this, are you getting this, everyone? We are dividing it into strips like this. So each strip has a different conductivity. Okay, I hope this is clear to everyone. So each strip has a different conductivity. Now what we are doing, we are connecting a battery like this. Okay, we are connecting a battery like this and the current will flow in the thickness. Okay, so the current is flowing from the front semicircular cross section towards the back semicircular cross sections, and all these strips, alright, so all these strips will be considered to be connected parallelly because this entire place will be at one potential as battery is connected across, like the positive terminal of the battery is connected here. So all of them will be at the same potential. This rear cross sectional surface will be at the same potential. Okay, so the current will flow into this like this. Alright, so the different strips, they are connected parallelly. So my plan is to find out the equivalent resistance. All these elements, all these elemental strips, they are connected parallelly. So I'll find out the equivalent resistance and then I will divide EMF by equivalent resistance to get the value of the current. So that is the plan. Alright, now let's see how we can do this. So consider one such strip here, like at an angle theta. Alright, at an angle theta, consider a strip of width RD theta and realize that current is crossing it in the inward direction. Current is going into the screen. Alright, so in such a case, if we have to write the resistance, how do we write resistance? Resistance is given by rho L by A. Alright, so dr, that is the resistance of the elemental strip. Alright, I'm using small r because capital R has already been used for the radius. So rho is 1 upon sigma. Then L indicates the length along the direction of current flow, which in this case will be equal to this length. Okay, so L, and then A represents area perpendicular to the current flow. So if I'm talking about a strip like this, so the area for this particular strip would be this area. Okay, so how do we write this area? Or let me do mark it in another color maybe. So how do we write this area? So this area would be RD theta into T. So T times of RD theta. Check this out. Alright, and now because all the elements are connected parallelly, alright, therefore we will write 1 upon R equivalent, okay, is equals to 1 upon dr1 plus 1 upon dr2, alright, and so on, which ultimately becomes integration of 1 upon dr, so it will become integration of 1 upon dr, so that is tr d theta divided by L. The sigma also goes in the numerator, and sigma was sigma naught cos theta. So this is what we get, and also check the limits. Since we are integrating in terms of theta, the values of theta will be the limits. So theta is measured from the midline, alright, and it is measured in this direction. So this point will correspond to an angle of pi by 2, and this point will correspond to an angle of minus pi by 2. So the limits of theta will change from minus pi by 2 to plus pi by 2. So if we do this, minus pi by 2 to plus pi by 2, alright, it becomes what? It becomes T R sigma naught by L. Integration of cos theta is sin theta, alright, so sin theta will be there, then okay, sin theta will be there, and then I substitute the value, like the limits is minus pi by 2 plus pi by 2, so this becomes 1 minus 1 2, so it ultimately becomes 2tr sigma naught by L. Now what is this? This is the inverse of equivalent resistance. We are looking for current, alright, I think the current was asked, okay, so we are looking for current. So current is given by EMF upon R equivalent, which basically means you multiply EMF by this entire quantity because it is 1 upon R equivalent. So 2tr sigma naught by L. So E 2tr sigma naught by L. Let's check the option. E 2tr sigma naught. So D option seems to be the correct one. So we can check that D option is indeed the correct one. Alright students, so that is question number 3. Alright, that is question number 3. Now we'll go to question number 4. Let's have a look at this. So question number 4 says, in the shown circuit, all 3 capacitors are identical and have capacitance C microfarad each. Alright, each resistor has a resistance of R ohm, okay, and ideal cell of EMF V is connected as shown. The incorrect, so guys, please pay attention that we have to search for the incorrect statement. Also pay attention to the fact that in steady state there will be no current in the capacitors, which basically means that current in this circuit in the steady state, alright, current flows like this, and it also flows like this, alright. So basically the effective circuit in the steady state is this. Alright, and all the resistors have the same value R. So what will happen that all the current in both the branches will be V by 3R and V by 3R, which also means that the potential drop across any resistor will be V by 3. Okay, so if I assign a zero potential here, then all these points will be at zero potential. Okay, and then this point will be at a potential of V by 3. Alright, this point will be at a potential of V by 3, sorry, 2V by 3. Alright, because every time we cross a resistance, there is a potential change of V by 3, and here the potential will of course be V. Alright, so all these points have a potential of V. Now this will again have a potential of 2V by 3. This will again have a potential of V by 3. So these are the potential distributions. Okay, now understand, let's read the options. So potential difference across C3 and C1 is equal. So see, they are equal in magnitude. C1 and C2, they are equal capacitances and they are connected in series. Okay, so if they are connected in series, whatever charge comes on the first capacitor, the same charge will appear on the second capacitor also. Their capacitance is also same. So it basically means that the potential across C1 will be C equal to the potential difference across C3. That will always be the case because they have the same capacitance and they will have the same charge. So yes, potential difference across C3 is equals to, not because they are connected parallelly. So don't think that this option is written to indicate you that this is connected parallelly. It is there because they are connected in series and they have the same capacitance. So they will always have the same value of potential difference. Okay, so this is correct statement and therefore this will not be the answer. Now potential difference across C3 plus potential difference across C1 will be equal to the potential difference across C2. Again guys, notice that this point, okay, keep looking at this circuit and then map that circuit. So this point have a potential of 4V by 3. Okay, so all these points have a potential of V by 3 and this point has a potential of 2V by 3. Alright, so difference between this point and this point is V by 3. Okay, here we have 2V by 3, you can see here, this is 2V by 3, this is V by 3, so difference is V by 3. So, and then the potential difference across C1 and C3 and they are equal. So the overall potential difference here will be divided into two equal parts. Alright, so it basically means that the potential difference across the C1 capacitor will be V by 6 and similarly the potential difference across the C3 capacitor will be this much. Also notice that this point is at 0 potential, this point is at 0 potential and this point is at V by 3. So the potential difference across the C2 capacitor will be V by 3. Now we can check any of the options. So potential difference across C3 plus potential difference across C1 is equals to potential across C2. This is correct and therefore it will not be answered. We are looking for the incorrect option. Potential difference across C2 is V by 6. So this is the incorrect one. So this has to be the answer. So option C will be the answer to this question as we can see here. Alright. So that is question number 4 for you. Now we'll go to question number 5. Let's see what this question says. So question number 5. If an ideal cell of EMF 5 volt is shown in the figure, as shown in the figure gives a power of 80 watt. Okay. Find the powers consumed by the resistors 2 ohm and 1 ohm. So guys, the question says that this ideal cell, so ideal cell there is no internal resistance, it has the EMF of 5 volt and it is giving a power of 80 watt. So the power given out by a cell is written as the EMF into the current flowing through it. Alright, the current passing through it from the negative terminal to positive terminal. So we can calculate the magnitude of this current as 80 by 5. 80 is the power, EMF is 5. So this current will be 16 ampere. And we also know that because this cell is giving out power, the current in it must flow from the negative terminal towards the positive terminal. So we are now aware of the current in this branch. The current in this branch, it's definitely 16 ampere and it is definitely towards left. Alright, now the current in this branch is shown to be 5 ampere. Okay, which means that the current in this branch will be equal to 21 ampere. So we are aware of the current flowing through the 1 ohm resistor. We are aware of the current flowing through the 2 ohm resistor. So the power developed in 2 ohm resistance. Alright, let me write it as P2. So that power will be equal to 16 square into 2. I square R I am doing. So 16 square into 2. That would be 514 I believe. 512. Okay. Watt. Okay. And then power produced in the first resistor, that will be the current flowing through the first resistor is 21. So not the first resistor, the resistors with 1 ohm resistance. So 21 square into 1. So that would be equal to 441 watt. Now we have to write the power consumed by 2 ohm and 1 ohm. So we should follow that order. So 512 and 4. So see, A option and C option, they differ only in the order. The numerical values are same. Because 2 ohm is written first here, the first number should indicate the power produced in the 2 ohm resistance. So therefore between A and C, I will go with option A. Option A should be the right one. Alright, as we can see here, option A is indeed the right one. Alright, now that was question number 5. We'll now go to question number 6. Okay, so what does this question say? A few statements are given pertaining to the figure, given figure below. So guys, it's a capacitor. Alright, the area of the plate is A and the capacitor is filled with two layers of dielectric of unequal thickness. The upper layer has a lesser thickness of d by 3, the lower layer has a more thickness 2d by 3. Alright, the charge density here is sigma and the charge density here is minus sigma. Now, the ratio of the energy density in the first dielectric to the second dielectric. Alright, so how do we calculate the ratio of the energy density? Okay, okay, so what we'll do, the energy density is given by what? Energy density is given by half epsilon E square. So this is how we write the energy density. Okay, let me first read all these statements. The ratio of the energy density in first dielectric to the second. Alright, so statement 1 and 2, they talk about the same quantity. Total induced surface charge density on the interface of the two dielectric is total induced surface charge density on the interface of the two dielectric. Alright, that's a pretty difficult one, I would say. Total induced surface charge density on the interface. Alright, so statement 1 and 2 talk about the same quantity. Statement 3 and 4 talk about the same quantity. Let's focus on each of them one by one. So the first statement says ratio of the energy density. Alright, now when we first talk about the energy density, the formula that comes to mind is this, half epsilon d square. So the half epsilon d square, so this is the formula for energy density. Okay, now how will we write E? How will we write E here? Okay, so can we write E like this, like half, then epsilon, then E can be written as sigma by epsilon square. Alright, because a medium is present here, so we will write epsilon not K instead of simply epsilon. Alright, so this becomes what? So this becomes sigma square upon 2 epsilon. So what I learned is that the energy density is inversely proportional to epsilon. Alright, and this can further be written as sigma square by 2 epsilon naught K. Alright, so the energy density is inversely proportional to K. So if we are talking about energy density in 1 and energy density in 2, it will be K2 by K1. So it will be 5:3. Alright, so 5:3. So between statement 1 and 2, statement 1 is correct, 2 is incorrect. Alright, so we have obtained between statement 1 and 2. Now let's pay attention to 3 and 4. So total induced surface charge density on the, so how do we write the induced surface charge density? Okay, so for this let's understand what is going on. Okay, so this is the plate, and let's say this is one of the dielectric. I am deliberately showing it away from the plate. Alright, and let's say this is the second dielectric. Okay, this is the second dielectric. So what will happen, and let me draw this lower plate also. So this is the lower plate. So in what happens actually is that we have some surface charge density here which we are representing as sigma, let's say sigma. Alright, we will get some induced charge density here, let me call it as sigma induced 1. Okay, this will be negative. The same value, the same magnitude will appear here with a positive sign, let me call it as sigma induced 1 with a positive sign. Alright, here again you will have negative charge density but with a different sigma, so this is sigma induced in the second one with a negative sign, and here again we'll have a positive. Okay, here again we'll have a positive value, and this positive value will be given by plus sigma I2, and here we will have negative values, and this negative value will be equal to sigma minus sigma. So this is how the charge densities are present here. Now the question talks about, the statement talks about total induced surface charge density on the interface of the two dielectrics. So we are talking about the net value of this. So we are actually talking about the net of these two. So one has sigma 1I and the other has minus sigma I2. So what is the net charge here? Like if we merge these two surfaces, then some positive charge and some negative charge will be neutralized, and then what is the net sigma left here? That is what we want to discuss. Okay, so how to solve this particular question? So what we are actually looking at is one layer of charge with a certain amount of charge density, maybe positive, maybe negative. So, let me write it as sigma x, like there may be some density here. Okay, there may be some density here. Now we understand that the electric field in the upper plate would be stronger, alright, because it has lower value of K. Here the K is 3, here the K is 5. So electric field in the upper region will be stronger and it will be directed downward, alright. So we can expect electric field lines like this. Okay, they are coming like this, and then here the density of the electric lines has reduced, so they have become far apart. So the electric field here is E1, the electric field here is E2. Alright, now if I consider any area here, let's say dA area here, alright, okay, or let's say I consider a cylinder here with a cross-sectional area of dA, alright. So in this cylinder, the net flux coming out of it will be given by E2 minus E1 into dA, and this will be equal to the net charge in the cylinder. So net charge is the charge on this surface, so that will be given by sigma x. This is the sigma we are trying to find out, into dA, so upon epsilon naught. Alright, so from here dA gets cancelled, and the value that we are looking for, sigma x, that would be E1 minus E2 and then into epsilon naught. Okay, now how much is E1 and how much is E2? So let's do that. Okay, so the answer that we are looking for is E1 minus E2. E1 will be given as sigma by epsilon naught. Let me just check whether I wrote E1. It's actually E2 minus E1. I wrote it incorrectly. It's E2 minus E1. Okay, E2 minus E1. Okay, so sigma by epsilon naught K2 minus sigma by epsilon naught K1 multiplied by epsilon naught. So we get sigma and then 1 upon K2 minus 1 upon K1. Alright, so this is the sigma we get. What is the option says? The total induced surface charge density on the interfaces. Okay, so actually guys, both the statements could have been incorrect. Okay, so let me put the value of K2. K2 is 5. Okay, so sigma 1 upon 5 minus 1 upon 3. So this becomes sigma, then 3 minus 5, that is minus 2 upon 15. Alright, so this is what we are getting. So which statement is correct now? Minus, so total induced surface density, so statement 3 is correct. So 1 is correct, 3 is correct, alright, and 2 and 4 are false. So I think you are not able to see the options here. All the options are not visible in the video right now. Okay guys, the answer is D option. So D option is 1 and 3. Okay, that is the correct answer. So the video is, it is getting cropped a bit, I can see that. But anyways, the answer is like statement 1 and 3, they are correct, and that is given in option number D. Okay, so D option would be the correct one for this. Okay, now we'll go to question number 7. Okay, now what does this question say? The figure shown is a part of a circuit at steady state. Alright, I hope the figure is visible to you everyone. Okay, so this figure is at steady state. Select the incorrect statement. Alright, so if the circuit is at steady state, then all the capacitors in this circuit, no current will be flowing through the branch containing the capacitors. Okay, and yeah, a lot of things are there. Okay, have we given the current anywhere? No. So potentials are given, nothing else is mentioned. Okay, so let me start writing the potentials at wherever it's possible. So this place is shown grounded, so 0 potential here. Okay, this point is also shown grounded, so 0 potential here. Okay, then we have a battery of 10 volt. Okay, so this place will have a potential of minus 10 volt. Alright, because the positive terminal is towards the ground. So what we can do, let's erase this. See, there is no current flowing in this branch. So if there is any current coming in the 4 ohm resistor, it is going into the 2 ohm resistance. Alright, so I can consider these to be these two as connected in series. Alright, and in that case, like if we can do that, so this 2 and this 4, this becomes 6. Okay, and then this 6 becomes in parallel with the 3 ohm, so that becomes 2. 6 and 3 are parallel connected, equivalent value will be 2. So Let me redraw the figure here. So from the top there is a resistance of 2 ohm, and then this becomes the point P. From point P there is one resistor, okay, and this resistor has a value of 2 ohm. This 2 actually is the equivalent of 3, 2 and 4. So we have drawn all of them, okay. Then from this point P there is another resistor here, and this resistor is 1 ohm, okay. And apart from this, this point has a potential of 3 volt, okay. This point has a potential of 3 volt. This point has a potential of 4 volt, okay. Yeah, that is the situation, okay. This point is P, so yeah, and below 2 ohm we have a resistor of 4 ohm. Let me draw that also. So we have a resistor of 4 ohm here, okay. Then we have a battery here, okay, and this point has a potential of 0. So if this point has a potential of 0, then we already marked that the potential at this point would be minus 10 volt. All right, now what we can do after getting the circuit like this, we can now write the node rule at point P. So if the potential at P is Vp, which we don't know, the equation that we can write is Vp minus 3 by 1 plus Vp minus 4 by 2 plus Vp minus 10, so Vp plus 10, okay, by Vp plus 10 by 6, okay, yeah. So this should be equal to 0. Now to solve it, we can multiply this entire thing with 6. Let's do that. If I multiply this entire thing with 6, this gets cancelled out, so this is into 3 and this is into 6. All right, so what I am left with is somehow it is getting connected. Anyway, I've tried multiple times, it is not working. Okay, so this will then become 6 Vp plus 3 Vp, okay. This 2 has got cancelled, so 6 plus 3, 9 plus 1, 10 Vp. I'll do it on the next page now. So we are getting 10 Vp, okay, 10 Vp and what? Minus 18 minus 12, so that's minus 30. Minus 30 plus 10 minus 20, that will go on the other side, so is equals to 20. So we get Vp as 2 volt. All right, so we have obtained Vp. I think that's a big victory. So potential at point, we have to select the incorrect statement. So A is correct, therefore it is not the answer. Charge on 2 microfarad capacitor is 8 microcoulomb. Okay, so if we know the potential of point P as 2 volt, okay, we have discovered that the potential of point P is 2 volt. What else can we discover? So we can discover that there is 2 volt, this is minus 10, so potential difference is 12. 12 by 6 is 2 ampere. So the current flowing in this branch is 2 ampere, and therefore the potential difference across the 2 ohm resistor, is 4 volt I into R, and whatever is the potential difference across the 2 ohm resistor. All right, so 2 ohm came because 2 ohm is actually the parallel connection of 3 and 6. So the same potential difference across exists across 3 also, the same potential difference exists across 6 also. So we can say that the potential difference here is 4, and therefore the charge on the 2 microfarad capacitor would be 8 microcoulomb. So statement B is also correct, and therefore it is not the answer. The current flowing from the 3 ohm resistor is 1 by 3 ampere. Now we have obtained the potential difference here as 4. Alright, so the current flowing through this 3 ohm resistor would be 4 by 3 ampere, not 1 by 3 ampere. So option C should be the answer because C is incorrect. Let's take D option also. In steady state, 4 ohm resistance can be assumed to be connected in series with the horizontal. The 4 ohm resistance can be connected in steady state. The 4 ohm resistance can be assumed to be connected in series with the horizontal. Yeah, we already did that. 4 ohm, 2 ohm. So D option is also correct. So C is definitely the answer, and we can see also C is the incorrect one. So that is the answer. All right. Now we'll go to question number 8. Okay, here. So what does this question says? So in a series LR circuit, okay, in a series LR circuit, the voltage drop across the inductor is 6 volt and across resistor is 8 volt. The voltage applied and the power factor of the circuit. I think that's a very easy question, guys. We have a series LR circuit, so that's an inductor, that's a resistor. The voltage across the inductor is 6 volt and the voltage across the resistor is 8 volt. Alright, so we know that the voltage of the source will be square of this, like it is VL square plus VR square and root of this, so it will become 10. Alright, so 10 volt. Now the question says that the power factor of the circuit. So you know, VR indicates I into R. So 8 volt is I into R. Alright, VL indicates I into XL. So that is 6. Alright, so the angle that Z will make, that is what? 37 degree. Alright, so so cos 37 is 4 by 5. So 0.8. So 10 and 0.8. So option B looks to be the correct one. Alright, so option B is the correct one here, as you can see. Okay, so that was question number 8. Now we'll go to question number 9. So what does this question say? A rectangular loop of side of length L and B is placed in XY plane. A uniform but time varying magnetic field of strength this much. A uniform field but time varying strength of magnetic field. The magnitude of the induced EMF. Alright, guys. So we have kept a loop in the XY plane. So if this is X axis and if this is Y axis, okay. Let me not draw it here. So let's say this is X axis, okay. Let's say this is Y axis. We have kept a loop in the XY plane, okay. Now the magnetic field has a X component this much. This will not contribute in the flux, ignore this. It has a J component, so J component will be in this direction. It will not contribute in the flux, ignore this. So it has a K component also which will contribute in the flux, and that K component is 10T square. So 10T square multiplied by the area. So area is L into B. Okay. So this is the flux. Alright, we want to know the magnitude of the EMF. So time derivative of this will give us the answer. So 20 TLB. So option C is the correct one. I think that was a pretty easy question. So 20 TLB is going to be the answer. Alright, we'll now move to question number 10. Let's say what this question has to say. It says in the circuit shown, switch is closed at t equal to 0. Immediately after closing the switch, the currents are I1, I2 and I3. And they are found to be. So we have been given the currents I1, I2, I3, and I2 and I3 they are 0. So question says that I2, I3 they are 0. I2 is the current in this branch, I3 is the current in this branch. Alright, the value of the resistance R is. So guys, let's try to understand here. When we close this switch, okay, when we close this switch, what happens? Like this branch has 0 current and this branch has 0 current. It is, we have been told this, okay. If these two branches have 0 current, okay, then this branch will also certainly have 0 current because node rule must be applicable. So this has 0, this has 0, this has 0. So this branch doesn't have any current, this branch doesn't have any current, this branch doesn't have any current. Okay, so it basically means that at t equal to 0, whatever current was there, it flowed in a circuit like this. So this is the circuit, and switch is closed. Immediately after closing the switch, the currents are, the value of the resistance are before closing. Okay, so capacitor had 0 energy. The capacitor had 0 energy, so capacitor will also behave as a connecting wire. Now if the capacitor is behaving as a connecting wire, then it's a single loop circuit and the current is given to us as 1.4. Alright, so 1.4 will be written as EMF. This is a single loop circuit now. So EMF upon R, so the value of R will come to be 10 ohms. Alright, so option B would be the correct one here. Is that okay, everyone? Alright, now we'll go to next question, which is question number 11. Okay, this question says 4 resistances are connected by an ideal battery of EMF 50 volt. Circuit in the steady state. Circuit is in steady state. Then the current in wire AB. Okay, so this circuit is in steady state, although there is no capacitor. So yeah, there was no need to. Okay, it's okay. So 50 volt. Now because this wire, because of this wire, this 2 and 3 they are connected parallelly. All right, and this 1 and 4 they are also connected parallelly. So the equivalent of 2 and 3 will be 2 into 3 by 5. So that would be 1.2 ohm. Alright, and the equivalent of 1 and 4 will be 1 into 4 by 5. So that is 0.8. Now the equivalent of this, they are connected in series. So the total resistance is 2 ohm. So we now know that the current that is flowing in this branch, it's 50 by 2. Okay, so 50 by 2, so 25 ampere current is flowing. We know that. Okay, so 25 ampere current is flowing, that's fine. Okay, now we want to know the current in wire AB. Okay, so guys, this circuit, like when we replace this circuit, so the equivalent of these two was 1.2, correct? And the equivalent of these two was 0.8. So using this we can calculate the potential difference across this combination. Alright, so if this is V1, so in this figure this is V1. Okay, so how much is V1 then? So 25 ampere passing through 1.2. 25 into 1.2, how much is that? Okay, 25, is it 30? So V1 is 30 volt. Check this. Okay, and if V1 is 30 volt, then V2. Okay, V2 will certainly be 20 volts. So we now know the potential difference across all the resistors. Okay, and therefore what we can do, I can calculate the current in the 3 ohm resistor. How much is it? The potential difference is V1, which is 30. The resistance is 3 ohm. So the current in it will be 10 ampere. So in this resistor, current is flowing in this direction, and this is 10 ampere. Okay, this is 10 ampere. The current in this resistor, can we find it out? Of course. The potential difference across the 4 ohm resistor is 20. So the current in this branch is 5 ampere. Alright, so 10 came, 5 moved in this direction. So the other remaining 5 must have gone upward. So the current in branch AB is 5 ampere, and it is from B to A. So the answer to this question would be 5 amperes. Okay, we have to answer in amperes. So the answer would be 5. Okay, as you can see here. Now, question number 12. What does this question says? The shown circuit is in steady state. Okay. Now switch S is closed. Okay. So the circuit was in steady state earlier. That means 20 microfarad and 30 microfarad capacitors, they had charge on them. Alright. How much charge we can calculate? We'll see whether we want to, whether we need to or not. Calculate the magnitude of the charge flown through the battery after closing the switch. Alright. Okay. So before we close the switch, the battery was connected to one capacitor, the value of which was 20 into 30 by 50. So that would be 20 into 30, 600 by 50, 12 microfarads. Alright. So the equivalent of 20 and 30 is 12 microfarad. So the battery of 30 volt was connected with a capacitor of capacitance 12 microfarad, which means that the charge here would be 12 into 30, so that would be 360 microcoulombs. Alright, so that was the situation. Now once this switch is closed, this 30 and 10, they come in parallel, so the equivalent becomes 40, and 40 and 20 are in series. So now the equivalent becomes what? It becomes 40 into 20 divided by 60, so that's 40 by 3. Okay, so 40 by 3 microcoulombs. Now the circuit becomes that there is a 30 volt battery which is connected with one resistance, the value of which is 40 by 30. Alright, the value of which is 40 by 30. Alright, so how much charge will be there on this plate? The EMF is 30, so 30 into this, so 3 gets cancelled, 10, 400 microcoulomb. Alright, so 400 microcoulomb. So earlier it had a charge of 360 microcoulomb. Now it has a charge of 400 microcoulomb. So how much extra charge came? 40 microcoulomb. So the answer would be 40. The answer to this question would be 40, as we can see here. Alright students. So that was question number 12. Now we'll go to question number 13. Okay, now what does this question says? Three identical uniform conducting rods, each of length A, which is 20 centimeter, are used to form a triangular loop PQR. The loop is then suspended from one of its vertices so that it can rotate about the horizontal fixed smooth axis CD. Initially, the plane of the loop is in the vertical plane, a constant current I is flowing in the loop. Okay, so we have been given the value of current, and we have been given the length of the equilateral triangle, the side length of the equilateral triangle, so we can calculate the area, and therefore we can also calculate the magnetic moment of this triangular loop. Okay, total mass of the loop is 60 gram, and this mass can be assumed to be concentrated at the centroid of the triangle. Okay, find the minimum value of B in millitesla so that the plane of the loop becomes horizontal during its subsequent motion. Okay, so what do we do? A loop is suspended from, so that at t equal to 0. Okay, so we are switching on a magnetic field. So I was looking for this statement. Okay, we have switched on. So there was no magnetic field earlier, and now we have switched on a magnetic field. So the moment a magnetic field is switched on, it will start exerting a torque on the loop. Why? Because this loop has a current in it, so there is a magnetic moment which is inward. Okay, so magnetic moment is inward, magnetic field is upward, so mu cross B, so there will be a torque. So this loop will begin to rotate. But as this loop rotates, the angle between the magnetic moment and the magnetic field, that will change, which means that the torque will change. Torque will still be there, but the torque will change as the loop starts rotating. So the torque is changing. Okay, okay, the torque is changing. We want to know that what is the minimum value of B so that the plane becomes horizontal even for an instant. So the situation that we are looking for is in which like just a minute, in which the loop attains the horizontal situation even for one, something like this. So it is vertical, it went like this. Okay, so if I consider this as the initial position, if I consider this as the final position, what is happening? Because of the magnetic field, there is a torque. So I'm going to write the energy equation. All right, because we are talking about an instant, we are not going to balance the torque in this position. In fact, in this position, the torque will become 0 because magnetic field becomes parallel to the magnetic moment. So we are going to balance we are going to write the energy equation. Okay, so how are we going to write? We are going to write initially the magnetic the interaction energy between field and loop. How do we write it? It is minus mu dot B. So minus mu dot B in the initial situation. Okay, then the gravitational energy in the initial situation. So if I consider this as 0 height, then the gravitational energy was negative minus mgh, and finally we got some different value of the interaction energy. All right, this we'll find out, and the gravitational energy became 0 because the center of mass was at the 0 height. So this is the equation we want to write. Okay, now pay attention. Initially the angle between magnetic field and magnetic moment is 90 degree. Initially it is 90 degrees, so this is 0. Alright, finally they both come in the same direction. The loop, okay, the loop goes inside, okay, so yeah, so they both become parallel. Okay, so theta becomes 0. So the equation that like this equation will transform into this equation, like it will become minus mgh is equals to minus mu b cos 0. So this is what we are going to write. So minus minus we can get rid of it. So mgh, now h is what? So h is the distance of center of mass from this line CD. So this entire height would be a sine 60, that is a root 3 by 2, and then h would be 2 by 3 times of this. So 2 by 3 times a by root 3. 2 by 3 times means a by root 3. Okay, and then mu, magnetic moment, how much is that? So current into area. How do we write area? Half into base into height. Height is root 3a by 2, and then into magnetic field. Okay, so this is the equation that we are going to solve. In this equation we are looking for the value of b. Okay, a gets cancelled, one of the a gets cancelled. Okay, and then it becomes like we are trying to look for B, so it becomes M into G. We have taken care of this. Root 3 and root 3 becomes 3. Okay, so we have taken care of that. Okay, then 2 and 2 becomes 4, so 4 comes here. Okay, then there is an I that will go there, and there is a. Alright, so now we need to substitute the numbers. Okay, so let's do that. So mass, how much was the mass? It says side length A is 20 centimeter. Okay, current is 10 ampere. Fine. Okay, mass is 60 gram. Total mass of the loop is 60 gram. Here there may be a trick, like the question may give you the mass of one rod, so you have to calculate that. Here we have given the total mass, so we are happy with it. Okay, and yeah, that's it. And we have to calculate the value of B in millitesla. So mass is 60, A is 20 centimeter, 60 gram, 20 centimeter, 10 ampere. Let's see. Okay, so 60 gram, so that is 60 into 10 raised to power minus 3. Alright, 60 gram into G. G is 10. Is the G given as 10? Is the G given as 10? Yeah, G is given as 10. Okay. Okay. Then 3. Current was, I think it was 10 ampere. And A was 20 centimeter. Yeah, current is 10 ampere. So 10, and then A was 20. So it will become 20 centimeter, it becomes 0.2. Now let's see whatever we can cancel out. So this 10 and this decimal goes away. 3 to 6. So this becomes 10. So 10 into 4, that's 400. Okay, 400 into 10 raised to power minus 3 Tesla. So 400 millitesla should be the answer. Let's have a look whether it is correct or not. Yeah, 400 millitesla is correct. Alright students, so that was question number 13 for you. Okay, now we'll go to question number 14. Okay, now what does this question say? This question says that wires P1 Q1 and P2 Q2, each of length 40 centimeter, has a resistance of 2 kilo ohm. So there are two wires P1 Q1, P2 Q2. They both have the resistance of 2 kilo ohm. Are both made to slide on the rails in the same direction with the same speed of 5 meter per second. In this region, a magnetic field of 1 Tesla exists. The electric current in the 9 kilo ohm resistor is K by 10. So this is a simple question actually. Each of the sliding rod will behave as a battery with some internal resistance. So magnetic field is inside. The velocity is towards right. I think the same direction. So it doesn't matter left or right. Okay. So if I'm assuming that they are moving towards right, so the P1 Q1 branch will behave as the battery with some internal resistance. Okay, let this value be E. Let the resistance be small r. The P2 Q2 branch will also behave similarly. It will behave as the battery of EMF E with the same resistance R. Alright, so this is, let's say, P2 Q2, and this is, let's say, P1 Q1. Okay, and they are both connected with this 9 kilo ohm resistance, and we want to know the current in this. Okay, it's very simple, guys. So these two, we can find the equivalent EMF. They are parallelly connected batteries and they have the same EMF. So equivalent EMF will be E, and the R equivalent will be R by 2. Alright, so the current that we are looking for would be E divided by R by 2 plus 9 kilo ohm. Let me do it on the next page. So we are looking for E divided by R by 2 plus 9 kilo ohm. So this will be the answer. Now E will be given by VLB. So VLB divided by R by 2 plus 9 kilo ohms. So let's do this. So let's check the data. So length is 40 centimeter. We'll remember this. Resistance is 2 kilo ohm. Okay, magnetic field is 1 Tesla and speed is 5 meter per second. Alright, let's try to substitute this quickly so that we don't forget. So V was 5. Length was, I forgot, I think 20 centimeter, 40 centimeter, so 0.4. So length is 0.4. Magnetic field was 1 Tesla. This resistance was 2 kilo ohm. So by 2, 1 kilo ohm. 1 kilo ohm plus 9 kilo ohm, that's 10 kilo ohm. So 10 into 10 raised to power 3. Alright, so the current that we get, how much is the current? So 5 into 0.4 is 5 into 2, 0.2. So that is 0.2 milliampere. Now, in what unit do we need to answer? It says K by 10 milliamperes. K by 10 milliamperes. Alright, so we have found, so this is K by 10. So if this is K by 10, then K is 2. Okay, so the answer to this question would be 2, as we can see here. And this brings to us to the last question of this test. This says in circuit initially capacitor and inductor do not have any energy. So capacitor and inductor, they don't have any energy. The switch is closed at t equal to 0. Alright, the moment we close the switch, an uncharged inductor will behave as an open switch, because the current in the inductor cannot change suddenly, so it will continue to allow zero current through it, so it will behave as an open switch, and the capacitor behaves as a closed switch. Okay, so find the ratio of the current flowing in the battery immediately after closing the switch. So the moment we close the switch, we can discount this branch. Okay, we can discount this branch because no current can flow through this. Okay, and this will behave as a connecting wire, so the equivalent resistance will be 9 by 2. If the equivalent resistance is 9 by 2, then the current flowing through the battery right after closing the switch, 18 by 4.5, that is 4 ampere. Okay, now long time after, so it says long time after closing the switch. Long time after closing the switch, the behavior changes. The capacitor will not allow any current to pass through it, but the inductor will allow current to pass through it. Alright, so long time after, this branch doesn't allow any current through it. Alright, so the inductor becomes a connecting wire, so equivalent resistance is still 9 by 2. And therefore the current through the battery still remains the same, so the ratio will be 1. Okay, so the answer to this question will be 1. Alright students, so that brings us to the conclusion of physics section of the entrance test 3 of Eklavya that happened on October 2nd, 2024. I hope you enjoyed the questions that I gave here. If you want to write the test link is present in the description of this session. You can click on that link and you can begin the test irrespective of when you are watching this session. The test link is always active. You can write the test in the test format. There is also the PDF available of the entire test in the description of this session. You can click on the link and you can make use of that PDF also. I hope we were able to teach you something. I hope that many of you achieve your dream, all of you achieve your dream, whatever you dream of. So take care students. Bye-bye.
Hello everyone. So let us now discuss the chemistry part of your Eklavya test. So guys, in this chemistry part of this test, the chemistry is quite time consuming, I'll say, because there are certain questions, certain numericals which are a bit lengthy, and of course that will take a lot of time. So time management you have to see in this paper, especially chemistry, where you feel there is a less time requirement as compared to the other subject. So this paper might consume a bit of more time as compared to the other papers in which the chemistry was there, right? So this paper's chemistry section is a bit time consuming, I'll say. So let us quickly see like the solutions, the questions that came in your test, and whether you get the right answer or not. Let's quickly discuss, guys. So the very first question in the paper, that was this, right? So the depression of freezing point of 0.01 molar aqueous solution of acetic acid is 0.02046, that is delta TF is given to you, molality of the solution is also given to you, and that is an aqueous solution, right? 1 molar urea solution freezes at minus 1.860 degrees Celsius, assuming molality equal to molarity pH of CH3COOH solution is. Okay guys, so now the next part of the information, 1 molar urea solution freezes at minus 1.86 degrees Celsius. This part of the question is only given so that you can calculate Kf, right, for water, which I'm sure that you already know. You are not, required to calculate that. I'm sure most of you must have remembered the value of Kf for water. So basically Tf is equal to Kf into M. You want to cross verify, you can calculate delta TF, you can put for urea. Molality is given to you, 1 molar urea solution. Kf you can calculate, that will of course come out to be 1.86, that is for water, right? So the urea part of the question is just to calculate Kf for water, right? Because this Kf you are going to use in the same equation when you apply it for acetic acid. Now because acetic acid dissociates, right? It can dimerize depending upon the solution. It dissociates in water. So delta TF is equal to I Ventov factor KF into M, right? Now we know the molality and we know the KF and also we know the delta TF. From here I can calculate the Ventov factor, that is 1 plus alpha for acetic acid because dissociation is there, right? So CH3COOH, it dissociates to give CH3COO negative plus H positive ion, right? So suppose the initial concentration is C, 0, 0. C1 minus alpha, alpha is the degree of dissociation which we can calculate from here because we know this, this and this, we can calculate Ventov factor I which will give us alpha for acetic acid here. So C1 minus alpha, C alpha and C alpha, right? So once we get alpha, we already know C, the concentration is 0.01 molar, right? Alpha we got to know from here. So the concentration of H positive ion is C alpha. C is 0.01 molar, alpha we just got it from here. So C alpha we got it, C into alpha, putting the value we can calculate pH because once we know the concentration of H positive ion, we can easily calculate what is our pH, minus log of H positive ion. So to calculate pH, we are just required to find out what is the concentration of H positive ion in this aqueous solution of acetic acid, guys, right? So not much calculations I will say, you can easily get it right. So indeed the answer to this question is, you can see here, the pH comes out to be 3 because the concentration of H positive ions comes out to be 10 raised to the minus 3 where alpha is 0.1, right? So I hope it won't take much time, this question specifically, if you are doing it in a right way. Let's move on to the next question, guys. Question number 2. In an ideal solution of liquid A and B, P naught A, P naught B is 7/3. Mole fraction of A is 0.25. How many minimum repeated distillations are required to obtain a small quantity of distillate having mole fraction of A more than 0.8? Now this question, I will say, this question is bit time consuming, guys, right? This question is bit time consuming. So basically you have an ideal solution of A and B in which the mole fraction of A is given, that is, mole fraction of A is given to you, XA in that solution is 0.25. That obviously means XB, the mole fraction of B is 1 minus 0.25, that is 0.75 in the solution, right? This information is already given. What else is given to us? P naught A upon P naught B is 7/3. That means P naught B is 3/7 times of P naught A. Right, guys? This is what it is. Yes, you can see. Now, question is how many times you have to do the repeated distillations. So what you will do? You boil the mixture, you get a mixture of vapors containing vapors of A and B. You condense that vapors to make a solution. Again, you vaporize it, collect the vapors in which again there is a concentration of A and B, right? There are vapors of A and B. So how many times you have to repeat this distillation so that in the distillate you have the mole fraction of A more than 0.8, right? So I hope the information which is given in the question is clear to you. Yes, guys. Now P total as per Raoult's law, that is P naught A XA, P naught B, that is 3/7 of P naught A XB. XA, XB values are given to us. Yes, XA I can put here, that is the value of XA is 0.25 and the value of XB is 0.75. This is the P total, guys, right? So this is the P total. The vapor pressure the total vapor pressure above ideal solution of A and B initially. Now, what is the mole fraction of A in the vapors, right? That is YA. I'm sure you all know YA into P total is equal to P naught A X A. These are the equations that we use in Raoult's law. YA is the mole fraction of A in vapor phase above the liquid. PT is the total vapor pressure. P naught A is the pure component A vapor pressure. X is the mole fraction of A in the liquid in the solution. So this is, I hope, pretty clear to all of you, right? Yes, so we can rearrange and calculate YA here. What is the mole fraction of A in the vapors, right? When we do distillation, YA is equal to P naught A X A upon P total. And we just got the expression for P total here in terms of P naught A, right? So we can put it here. XA we already know. P naught A into XA, that is 0.25 upon P total. We can put the expression here for P total. This expression also contains P naught A. So P naught A from numerator gets cancelled by P naught A from denominator, and we will get the value of YA, the mole fraction of A in vapors. Okay, now if we got YA, you know YB. The mole fraction of B in vapor is 1 minus YA. That means when we do the distillation, now we finally know how much mole fraction of A is there in the vapors, how much mole fraction of B is in the vapors. YA, YB. Now what will happen? We'll see whether this YA is less than or more than 0.8. Of course, it will be less than 0.8 because we need to do multiple distillation to get that concentration of, A in the mixture. So again, we have to do the distillation. So what we'll do? We condense these vapor in which Y and YB are the mole fractions of A and B, make it a liquid, right? Now again the same equations applies, but now YA becomes XA, YB becomes XB, right? Because the vapors you condense to form a liquid, right? Again you have to repeat all these equations to again get the new YA, YB. Check whether the YB, the mole fraction of, YA is coming out to be 0.8 or more than 0.8. If not, then again repeat. So what you have to do? In the first step, calculate YA, YB. In the second step, use the same equation. YA is XA now. YB that you just calculated becomes XB now because we are condensing the vapors to form a liquid, right? So you have to do this multiple times until you get YA having mole fraction of A more than 0.8. Until you get YA is equal to greater than 0.8, right? So this is one such question which is time consuming because the equations are pretty basic, right? The Raoult's equation you are supposed to use. But it might take time because you are repeatedly using the same equation, putting the different values. You can, let me show you the solution also, right? Let's see. So this is of course the data given. You can check. So YA, YB we first calculated. Whatever YA, YB are coming, again we calculate the total vapor pressure because they become XA, XB, right? So same equations we are using. We calculate again the new YA, which is less than 0.8. Again we have to do the distillation. Then finally what we get, YA is 0.8089, that is of course more than 0.8. So how many times we have to do the distillation? 3 times we have to repeat the process, guys. So indeed the option that will be your answer is C, that is 3. You can check here. The same equations you are supposed to apply but 3 times, changing the value of XA and XB. Initially, right, it was given 0.25 and 0.75. Then the vapors, you have to condense them. They become the liquid. So YA becomes XA, YB becomes XB. Okay. Now the next question. An acetic acid solution mole fraction is given to you 0.02 in benzene freezing at 277.4 Kelvin when acetic acid exists as dimer calculate the equilibrium constant of dimerization, where the melting point of pure benzene is given. Enthalpy of fusion of benzene is also given. So what we have to calculate? We are supposed to calculate the equilibrium constant, right guys? So equilibrium constant you are supposed to calculate. So first let me write the expression for equilibrium constant only. So I have acetic acid where it is dimerizing. 2 molecules of acetic acid in benzene dimerize because of intermolecular hydrogen bonding, CH3COOH whole twice. Right? Okay. So initial concentration, molarity we can calculate for, because mole fraction is given. So molarity, suppose the total mole of the solution is 1 mole. So out of 1 mole, acetic acid is 0.02 moles and the remaining is your solvent, that is benzene, right? 0.02 moles is the moles of solute, that is acetic acid, and rest is your benzene. So rest is 0.98 moles of benzene into 78, the molecular mass of benzene. So moles of solute divided by mass of solvent, right, into 1000, because we have to take that in kg. This will give you the molality of the solution. Molality of which solution? Acetic acid solution, right, in benzene. Solvent is benzene. Molality equation I've used, you can check here guys. So on solving, this will come out to be 0.26. So the concentration, the molarity of acetic acid is 0.26. So initially it is 0.26, the initial concentration. So 0.26, 1 minus alpha or x, whatever you can take, 1 minus alpha also you can take, that is x by 2, right? So C alpha by 2, 0.2 x by 2, right, on dimerization. Now because the question they asked you the equilibrium constant, how you can calculate the equilibrium constant? The concentration of this dimer upon the concentration of this acetic acid raised to power 2. This way, the concentration of dimer is 0.26 x by 2 and the concentration of this is 0.26, 1 minus x square, right? Square. So to calculate Kc, you need to calculate x, or if you are using alpha instead of x, so alpha you are supposed to calculate. Rest all the information is given to us to calculate x, or you can say alpha, right? Because to calculate equilibrium constant, I need that x value. So guys, please see the question again. You know freezing point, right? And the melting point of pure benzene is also given to you. Enthalpy of fusion is given to you. So I am sure this formula, enthalpy of fusion of benzene, is given to calculate the Kf of benzene, right? RTF square by m upon 1000 delta HF. This is the formula by which you can calculate Kf for benzene as a solvent, Kf of the benzene, using this enthalpy of fusion data, right? Melting point is also given to you. Enthalpy of fusion is also given to you. You can calculate Kf for benzene. Now, so once you calculate the Kf for benzene, what you are supposed to use the equation? Delta Tf is equal to I Kf into m, right? Delta Tf, I, Kf, you know, molality, you already know for benzene. Now, because it is dimerization, association is there. What is I here? What is I here? For dimerization, what is I? For dimerization, for association, I is 1 minus x by 2 or alpha by 2. Right? Yes, once you get I value from this equation, you can easily calculate x, put that x here and calculate the equilibrium constant. Right? So you are supposed to calculate equilibrium constant. For that you need x. To calculate x, you are supposed to apply the colligative properties, the depression in freezing point and all. Right guys? Yes? Got it? I hope you can calculate this question. Let me show you the solution also. So wherever you are making the mistake, you can check. So delta TF is equal to KF into M. You can calculate I, right? So please check. Your final answer will come out to be B, 3.1. Got it, guys? This was question number 3. Again, it might take like few seconds more than what is expected, that you should spend 2 minutes per question. So it might take little more time because the calculations are there. Now the next question, liquid A and B forms an ideal solution. P naught A, P naught B is given. Initially 1 mole of A and 1 mole of B are taken. Calculate the vapor pressure when 1 mole of mixture is vaporized. So you have liquids A and B which are forming ideal solution. You know the vapor pressure of the pure components P naught A, P naught B is also known. Initially you have a mixture in which there is 1 mole of A and 1 mole of B, right? So you are supposed to calculate the vapor pressure when 1 mole of the mixture is vaporized, right? I hope you got the question, guys. Question is clear to you. I hope so. The question is clear to you, right? Yes. Okay. Suppose NB moles of B is vaporized. Moles. That means the mole fraction of B in vapors above the liquid which contain 1 mole of A, 1 mole of B is moles of B, that is NB, upon the total moles. Yes. What is the total moles? 1 mole, because 1 mole of mixture is vaporized in vapor. The total mole of A and B is 1. This is YB, right? So if NB moles are vaporized from the liquid, the moles of B remaining in the liquid left in solution, liquid. Initially there was 1 mole of B and out of that NB moles are vaporized. So I have 1 minus NB moles that are there in the solution, right? Now the P total, you know, P naught A, the Rolled law, XA plus P naught B XB, right? This way you can write. Yes, P naught A, P naught B, XA, XB, and I am sure you are aware XA. What is XA? How can I write XA? I can write XA, P naught A is 1 minus XB, mole fraction of B, plus P naught B, XB. So the basic equation, from here I can rearrange this equation to get a equation in which XB is expressed in terms of P total, P naught A, P naught B, right? So I can get an expression of XB in terms of P naught A, P naught B and P total by rearranging this equation. Yes, guys? Perfect. So another equation by which I can calculate my XB, I can get the expression of XB is using the expression containing YA, YB. What is YA, YB? The mole fraction of A and B in the vapor phase, right? So what can I write, guys? What can I write? YB is equal to P naught B XB over P total, right? Yes. From here also I can calculate the expression of XB, rearranging. So from here I get XB expression, from here I can get XP expression. I can equate the two, put the values so that I can calculate P total. Because ultimately they are asking me what is the P total when 1 mole of mixture is vaporized. So you get two equations in terms of like P naught A, P naught B, PT for XB. Just equating those equations, you will get your desired result, and indeed the answer that will come out is C. So you can check here. If you have solved this question in the paper, I am sure you can do it pretty nicely if you get this concept, right? So ultimately the P total is under root of P naught B, P naught A. This is P naught A, guys. Right? That is 300 torque. Right? The same way, just I told you. Let's move on to the next question now. Okay. So the calculate the quantity of electricity in Faradays required to reduce 12.3 grams of nitrobenzene into aniline if the current efficiency is 75%. So Faraday's law. So what does Faraday's law says? Faraday's law says number of Faradays required, right? That is equal to the number of equivalents. Reduce or oxidize. Number of Faradays. Equal current mass, the equal equivalents are being produced. Yes. Now, how can we calculate number of equivalents? So, number of equivalents given mass divided by equivalent mass. Now, to calculate equivalent mass, we need, so nitrobenzene. Benzene this is converting to aniline. So how many electron is being transferred? What is the valency factor here, guys? What is the valency factor here? The molar mass is 123 upon valency factor or Z factor. Given mass divided by equivalent mass, that will give you the number of equivalents, right? Yes, the number of equivalents of nitrobenzene, because nitrobenzene is getting converted to aniline. Now calculate the oxidation states here, guys. What is the oxidation state of nitrogen here? Plus 3. Right? What is the oxidation state of nitrogen here? Minus 3. So nitrogen is going from plus 3 to minus 3. How many electron transfer per molecule? 6. So that is the valency factor, right? So the valency factor here is, this is 6. So number of equivalents is equal to number of Faradays passed. Yes? Correct? So you can calculate how many Faradays are passed. Yes? Because you are supposed to calculate quantity of electricity in Faradays only. Right? So you get Faradays passed. But the question is not ended here, because it is also given the current efficiency is 70%. The value you just got, that is not the final value, because the efficiency is 75%. You are supposed to get this value, so you have to calculate of what value the 75% value is this, that is coming out. So because the current efficiency is 70%, you are just supposed to calculate accordingly, and your final answer will come out to be 0.8 Farad. As you can see, so 0.6 is the Faradays that is coming out, and 0.6, the current efficiency is this. So you have to calculate how many Faradays you are supposed to give, so that ultimately there are 0.6 Faradays which are doing the reaction. Got it? So 0.8 Farad is the answer. That was question 5th, guys. Now let us move on to the next question. Specific conductance of 0.001 molar solution of sodium sulfate was this. So specific conductance is given to you, that is conductivity, right? So conductivity, you can check the units, is given to you. When saturated solution of calcium sulfate is added, specific conductance increases to 7 into 10⁻⁴ Siemens centimeter inverse. Calculate solubility product of calcium sulfate. Now this might take a lot of time, guys, to calculate the solubility product. KSP. You need the concentration of calcium ion. You need the concentration of sulfate ion. Right? Yes, in this solution. Perfecto? Both that is required. Now to get calcium ion concentration and sulfate ion concentration, we will do the entire drama. So one formula that I know, that is the solubility of how much it is dissolved. The solubility of calcium sulfate in the solution is 1000 into kappa, that is given to me, right? Yes, kappa upon molar conductance of calcium sulfate, right? So I need molar conductance of calcium sulfate. In the question, the molar conductance of sodium ion is given to me, calcium ion is given to me, not the sulfate ion, right? Because if I have to calculate the molar conductance of calcium sulfate, that is the sum of molar conductance of calcium, which is of course given, but I don't have the molar conductance of sulfate. So how to calculate that molar conductance of sulfate from the data given about Na2SO4, right? So molarity of Na2SO4 is given and specific conductance is given. We can calculate molar conductance of Na2SO4. Right? Molar conductance, we can calculate, we need molarity, we need kappa to calculate the molar conductance of Na2SO4. 1000 into kappa upon m. So kappa is given, m is given. Right? So I get the molar conductance of Na2SO4. So by using this value, Na2SO4 value, right, I can calculate sulfate ion, because sodium ion's molar conductance I already know. So I can calculate for sulfate ion, right? So that sulfate ion I can use here to calculate the molar conductance of calcium sulfate. So I got the molar conductance of calcium sulfate. Now how about this conductivity? So initially the conductivity was 2.6 into 10 to the power minus 4. When you add calcium sulfate, it increases to 7 into 10 to the power minus 4. That increase in the value, right? How much increase was there? 7 minus 2.6. That is 4.4. That 4.4 into 10 to the power minus 4 increase in conductivity, specific conductance, is because of calcium sulfate. So you got the kappa for calcium sulfate. Put the values, you will get solubility, right? And this solubility you can put here S, and sulfate. But please keep in mind, you already have sulfate ion from Na2SO4. So you are supposed to add 0.001 to this concentration. Bit lengthy question, I will say, right? So bit lengthy, guys. So here you can see the solubility. How you can calculate for calcium sulfate? Using this molar conductance into kappa. Kappa of calcium sulfate you can calculate from this equation. The difference between the two, the molar conductance of calcium sulfate, you need the molar conductance of calcium and sulfate. Calcium is given. Sulfate you can calculate from the molar conductance of Na2SO4, which you can easily calculate using kappa into 1000 upon m. Right, guys? Yes. So of course, bit time consuming again, but I'm sure not much is required. So the basic formulas that you are supposed to know that are being used here on molar conductance. Yes, guys, you can see here. So ultimately you will get the solution, right? So the answer indeed is B. Now, the interesting question. So consider the following first order parallel reaction. So you are considering the first order parallel reaction. K1 by K2 is 1 by 2. Calculate the total moles of reaction mixture after 75% of A reacts, right? 75% of A reacts. Initially, there were 2 moles of A that was taken. 2 moles of A was taken. Yes? Got it? So, suppose you started with A, right? You started with A. Now, suppose X moles of A is converting into B, right? X moles of A is converting into B. That means if X moles are converting into B, we get 2X moles of B. At the same time, because K1 by K2 is 1 by 2, That means K2 is twice of K1. The rate of second reaction is double than that of first. In the same time, if X moles of A are converting to B, so that means 2X moles of A are converting to C. So if 2X moles of A are giving C, that means 4X amount of C is being formed. Right? Yes. Now they have told us the total moles of reaction mixture after 75% of A reacts. And initially we have taken 2 moles of A. So we start with 2 moles of A, 75% reacted. That means 1.5 moles of A reacted. Right? So I can say X, the moles of A reacted to become B, and 2X, the moles of A reacted to become C. X plus 2X has to be 1.5. Because 75% of the reaction happened, right? So from here I can calculate the value of X, right? I got the value of X. Okay, now calculate the total moles of reaction mixture after 75%. So this is 0.5 remaining, 1.5 reacted. This is X moles of B is 2X, that is 1. The X value is 0.5. 2 into 0.5, that is 1, right? And how about C? C is 4X, that is 2. 4 into X, that is 4 into 0.5, that is 2. So the total moles, that is 3.5 moles, right? So the total moles, total 0.5 moles of A left, 1 mole of B form, 2 moles of C form, that is 3.5 moles in total. So the option A, B, C, it has to be D option, right? D is 3.5, right? So D option is 3.5. The answer indeed is 3.5. Got it, guys? So answer is 3.5. Now the next question. Consider the following elementary reaction. A plus 2B gives C. Initial pressure of A and B was given. Calculate the rate of reaction relative to initial rate when partial pressure of C was 0.3. So you are supposed to calculate the rate. Initial rate and final rate you have to calculate. Right? Let me see what the reaction is. So we have A plus 2B gives C. Right? Initially partial pressure of A is 0.4 and B is 1. After a while, this 1 minus 2x, this gives x, right? So calculate the rate of reaction relative to initial rate when partial pressure of C is, so the you have to calculate when partial pressure of C is this. That means x is, partial pressure of C is, x is 0.3. So when x is 0.3, if this is 0.3, right? How about this? The partial pressure of A remaining is, I hope you can get it. Just put the value of x, nothing else you are supposed to do. Yes, 0.1. And this is 1 minus 0.6, this is 0.4. Right? So, rate, because it is elementary reaction, rate is rate constant into the concentration of reactant raised to power the stoichiometric coefficient. The concentration of reactant raised to power their stoichiometric coefficient. Right? So you're just supposed to write the pressure of A and B initially 0.4 and 1. After the partial pressure of C becomes 0.3, that is 0.1, 0.4. So final rate is K into 0.1 into 0.4 square. And initial rate was K into 0.4, that is PA, and 1 raised to power 2. Got it, guys? So you are just supposed to take the ratio RF by RB, right? Yes, guys? This is you are supposed to take. Just take the ratio. Done? Done, 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 done. Got it, guys? So I hope you can do it nicely. Easy question. So the answer that you will get is 1 by 25. That is option B. You can see here, right? So rate of reaction is directly proportional to the concentration of reactant raised to power this stoichiometric coefficient, because the reaction given is elementary reaction. Simple. Okay, now the next question, which is from inorganic. Identify the true statement. Okay, you have to identify the true statement. So you can save your time in inorganic question, because physical chemistry questions consumed a lot of time, I'm sure. So you can save that time. You can manage your time by doing the inorganic chemistry questions quickly. So let us see. Identify the true statement. CuCl4 2 negative exists and CuI4 2 negative doesn't exist. Very true. Why this is true? Because I negative, right? That will reduce your Cu2 positive to Cu positive. So that doesn't exist. Very right. Next, the rhodium complex and then nickel complex. Both are tetrahedral and diamagnetic. No, of course not. This is square planar complex, guys. So that is also a false statement. Trimethylamine and trimethylsilylamine, they are isostructural? Of course not, because there is indeed one is pyramidal, another is not pyramidal because of back bonding, d pi p pi back bonding. So that is also not true. So the only option that is true is 1. Right? Yes, guys. So the answer is A. Next question. Match the correct code. Total number of stereoisomers for the following complex. I am sure this you should do rightly, because in the last solution of the last paper, I asked you to make sure that you know the stereoisomers of complexes. I have told you about the chart given in JEE, right? You just know that chart. You should revise that chart thoroughly so that you can save your time in doing such type of questions. All the complexes, all the probable complex journal formulas are given in that chart in JEE, right? And the number of geometrical isomers and the enantiomers and the total stereoisomers are given. Please make sure you know that. That will save a lot of time if you revise that repeatedly. Though you can do that question by considering all the possible cases, but that will consume a lot of time, and the probability to get somewhere wrong is also high in that case, right? I'm sure you should do it, right? Though the options are there. So you can see 3, 4, 6 is the answer. 3, 4 and 6, that is D donkey. But what I suggested is, please pay attention to that, right? Okay, the total number of correct statements are secondary valency is non-directional. This is false, of course, because secondary valency is the ligands, right? The number of bonds between your this CMA and ligand that defines the geometry. That is directional. Crystal field theory predicts the exact shape of the complexes. Of course not. And then platinum plus 4. Yes, this platinum and 4 coordination number, it is a square planar complex. True. This is a tetrahedral complex. Of course, it is also true. Common complex it is there. So 3 and 4 statement is true. How many statements are true? It is integer type. So you have 2 statements that are true in this. Now find the total number of complexes from the following which when kept in magnetic field loses weight. So which will lose when kept in magnetic field? The diamagnetic species in which the electrons are paired. So you have to figure out the diamagnetic species which repel the external magnetic field, loses weight, right guys? So in all these complexes you have to figure out those which are diamagnetic, in which the electron pairing will take place. So you can say we have to figure out those complexes which have either all paired electron because of the oxidation state of CMA, or the ligands which are strong field ligand that can lead to pairing of electrons. So diamagnetic behavior, right? So I can see CN is there, ammonia is there, and oxalato is there, CO is there, like strong field ligands, right? And strong field ligands. So you have to figure out the complexes which are strong field ligand, ammonia, oxalato, cyanide, and this ammonia is there, CO is there, and this in this zinc is having no unpaired electron. You can see the oxidation state of zinc right here. Zinc 3D10. Yes, 3D10 is there, so no unpaired electrons, so diamagnetic. So total number of complexes that are diamagnetic is 6 here. So you can check here. Diamagnetic species 6, that is the right answer. Now the next question, how many following statements are correct? Lanthanum hydroxide is less basic than lutetium hydroxide, false. As we move along the lanthanides, the basic nature of hydroxides decreases. So false statement. In lanthanide series, the ionic radius of Ln3 positive ion decreases because of lanthanide contraction. Yes. Next statement, La is actually an element of transition series rather than lanthanides. That is also true. The elements after lanthanum, they belong to F block. Lanthanum itself is in D block, right? Atomic radius of zirconium and hafnium are almost same because of lanthanide contraction, right? Yes, they are almost same. I hope you know this exception because of the lanthanide contraction, the poor shielding by 4f electrons. Yes. So how many statements are correct? So first was false, second true, third true, and fourth true. So 3 statements are correct, right? 2, 3, and 4, they are correct statements. Let's move on to the 14th question, which is on Arrhenius equation, guys. A reaction takes place at 300 Kelvin, right? A reaction takes place at 300 Kelvin. When catalyst is added, rate of reaction increases. Of course, when the catalyst is added, the rate of reaction increases because your catalyst gives an alternative pathway for with a lower activation energy. So when you add your catalyst, your activation energy decreases, of course, and that affects your K value also, right? Rate constant value also. So let's see further. Calculate the change in temperature in degrees Celsius, which would have the same effect on rate of reaction as that of catalyst. Okay. So assuming the catalyst changes the activation energy by 20%, so you are supposed to tell at what temperature the same K will be there as when you add the catalyst, right? So at what temperature the K value is same as the K value when catalyst was added, right? So this is the equation, you know, the Arrhenius equation. So when catalyst is added, suppose without catalyst, let me write the equation without catalyst. This is Ln K1 minus EA by RT1 plus LNA. When a catalyst is added, this is the rate constant, new rate constant, and the activation is say AC, the new activation energy. Rest everything is same for the reaction, right? So dividing equation 2 by 1, you will get ln of Kc by K1 is equal to, right, EA by RT1, right? EA minus EAC by RT1. So I can get that value. So please see, guys, it is just the Arrhenius equation that I wrote. So dividing the two equation Kc by K1, right? This Kc by K1, we divide these two equations, right? Nothing else we did. EA minus EAC RTY, right? This is, now in journal, you know, ln of K2 by K1 at different temperature, right? EA by R right? This is the equation, Arrhenius equation. Yes? Yo, please see. Oh, sorry. T1 by T. Yeah, this is 2. And put the minus sign outside. Let me write it again. Because we didn't take the minus sign here, so it will be minus. Right? Done? Perfecto? Yes. So now we read at what temperature the K2 value is same as that of Kc. Right? So ln Kc by K1 should be equal to ln K2 by K1 because we require the temperature at which this K2, at what temperature the K becomes equal to Kc. right? Just equate these two equations because you know T1 value, that is 300 Kelvin. You know EA and EAC because they told you assume the catalyst change the activation energy by 20%, right? So if it was initially 100, on adding catalyst the activation energy becomes 80. So if you take EA 100, take EAC 80. So you can solve and can calculate temperature T1. Yes guys, equating these two equations, you will get your answer. And let's see what did the answer that you got. 75. They asked you the change in temperature. That also you have to be very careful, right? Calculate the change in temperature. Don't tell the final temperature. Just don't quote the T2 value. Be cautious guys. Change in the temperature. T2 comes out to be 375. You are supposed to write fill 75. That is the change in temperature, as the initial temperature was 300 Kelvin, right? Okay, now the last question. You have a cell, right? And PK, PKB is given. Calculate E cell, EMF of the cell in volt, right? Okay. So next equation, E cell is equal to next equation I'm writing. Now let us look at the cell. So in the cell, we have the hydrogen electrode, we have the hydrogen electrode. That means this is a concentration cell. Both the electrodes are hydrogen electrode. Concentration cell, that means E naught cell is 0. Both sides we have hydrogen electrode, right? Yes, E naught cell is 0. Okay, now anode. Oxidation takes place. This is my anode on left side of the cell and this is my cathode, right? So anode and cathode we have. So at anode, what reaction is taking place, guys? At anode, what reaction is taking place? H2 gives 2H positive plus 2 electron. And at cathode, the same reaction is taking place, but reduction. 2H positive gains 2 electron and becomes H2. Right? Yes. So this is what is happening in the cell. So now just write the expression of Q. Right? So the overall reaction you are supposed to write on reactant side, we have concentration of H2, that is 20 at the anode compartment. On product side, we have concentration of H2, that is 0.2, right? The pressure of H2, that is 0.2 in the cathode compartment, and the concentration of H positive we need. Now for that, we know in anode compartment, we have this solution, which is a salt solution of a weak acid and a weak base. Remember salt hydrolysis, right? The pH of this will be, pH of this solution will be 7 plus half of pKa minus half of pKb. Ka, Kb both are same. Acetic acid, ammonium hydroxide, right? That means in this case, the pH comes out to be 7. That means the concentration of H positive ion in anode compartment is 10 to the power minus 7 molar. pH is 7 because we have a salt of weak acid and weak base whose pKa, pKb is same. So in anode compartment, the concentration of H positive ion is 10 to the power minus 7. Let's see the cathode compartment. We have a solution, salt solution of a strong acid and a strong base. NaCl, the pH is 7. The solution, NaCl solution, the pH is 7. That means in cathode compartment also the concentration of H positive ion is 10 to the power minus 7. So you know the pressure in both the compartment hydrogen, the concentration of H positive ion, that is 10 to the power minus 7. Put the value in Q, the next equation, and I'm sure you will get your answer E, and just quote your answer by multiplying it by 1000. Right guys? So let's check the answer. So the E comes out to be 0.059. As you can see, you put the values, right? And your 1000 E comes out to be, of course, 1000 E is 59, right? So you are supposed to quote your answer as 59. Got it, guys? Yes. So this was your answer. right? Okay, so that's all, guys. I hope you did really well in this test, and it is a bit time consuming. The physical chemistry question numericals, some are a bit lengthy, that might take more of time, but you can definitely save your time in inorganic questions. So all the best for the result, everyone.
Hello, welcome everyone. I am Surendra Jain, Master Teacher of Maths in Vedantu. Today I am going to discuss Eklavya Entry Test-3, which was conducted recently. This is question number 1 of that paper. We are given A as a 2 into 2 matrix, and we have to find the value of determinant of A into A transpose plus determinant of this thing. Here determinant of A and A transpose, they both are same. So using that property, we can write this as determinant of A square. Here determinant of A you can calculate, it comes out to be -3. So that portion will be 9, but we have to find what will be the result of this A raised to the power 12 minus adjoint of 3A whole raised to the power 12. Now to do this question, let's try to observe some pattern. There can be some theories also, but we can do this question with the help of a pattern. Please see how. If I find 3A, okay, it will be 9, 15, 0, -3. Okay, and from this, if I find adjoint of 3A, okay, so how adjoint of 3A is found, or adjoint of any 2 into 2 order matrix is found, we just interchange the diagonal elements. So it will be -3 and 9 here, and minus sign on the other two elements, so -15, and it will remain 0 here. Okay, so that will be my adjoint of 3A. Now suppose this power was not 12, okay, this power was not there. So if I have to subtract A with adjoint of 3A, so you can see here there is a 30 in the first column, here it is -30. Okay, now let's try to find out A square. Okay, so if I find A square, it will be 9 here, 10 here, because 15 minus 5, 10, 0 here and 1 here. Okay, now if I try to find adjoint of 3A whole square, okay, you can check the first entry now will be 9. Okay, this element will be 0 here. You can check it will be for this square will be 3 minus 3 into 15 is 45. 45 minus I think 105. It will be some value, let's say A. Doesn't matter actually, and you will get 81 here. Now what I am trying to tell you, that whenever you do the square or you do the square of adjoint of 3A, my first column will always have element 0 here, and these elements, this will be always 3 square, 3 cube and so on, whereas this will be -3, -3 square and so on. So if power is even, these two columns will always be same. That means if you subtract these two, my first column will become 0. So here we can assume that this thing, that determinant which we are looking for will be something like that. First two element of, or I can say first column will be 0, 0, and you will be having some element like x, y here. So the value of determinant for this part will be 0, and for this part we have already seen it is 9. So you can see the answer for this question will be 9. Okay, I think this is clear. What we did from A, we are getting A square, A cube. Every time you will be getting 3 raised to the power n and 0 in the first column. Whereas for adjoint of 3A, my first column is -3, 0. So if you do the squaring, you do the cubing, then you will be getting -3 square, -3 cube and so on. That means if power is even, my first column here will be same. So if you take the difference, my first column will become 0, 0. So the determinant value will be 0 for this particular part, and hence answer for this question will be 9. Okay, bit tricky question, but if you observe the pattern, I think not very difficult. Okay, now moving to the next question. Again a question of matrix only. We are given adjoint of 3 into 3 matrix P. So this is not P, this is adjoint of P, and we have to find the possible value of trace of P. Trace is sum of diagonal elements of P. Okay, we will use one property here. Okay, and the property here is that if you take adjoint of P, okay, this is the adjoint of P. If I take again adjoint, I think it becomes equal to determinant of P into matrix P. Okay, now here we can find the determinant of this thing. That means determinant of adjoint of P, because this is the adjoint of P, and you can check this after calculation comes out to be 4. Okay, if it is 4, and because adjoint of P determinant is actually determinant of P square, so that will be 4. So determinant of P will be equal to either +2 or it will be -2, because it's the 3 into 3 matrix. So power is n minus 1, so here it will be square, so P determinant value will be +-2. Now we have to find adjoint, we have to find the trace of P, that is sum of diagonal elements of P, which means I will only focus on the diagonal elements of this adjoint of adjoint P. We can write the cofactor of diagonal elements only, that will be 3 minus 7, that is -4 here. Then for the middle element it will be 3 minus 4, that is -1, and for the last one it will be 1 minus 8, that is -7. Other elements I don't need, so I will not write them. These elements I don't need, and it will be equal to plus or -2, because the determinant value of P is this into P. Okay, so for P the diagonal elements are actually 4, -4, -1, -7, and divided by plus or -2. So what will be my trace of P? My trace of P should be equal to -4 plus -1 plus -7, I think it comes out to be -12, and that will be divided by plus or -2. So it will be either +6 or it will be -6. So here you can see possible element, possible value can be, or possible value is. I think only one option is correct, that is C here. Okay, so moving to the next question. Yeah, this question is from function. We are given that fx is equal to under root of x minus 1 plus under root of this expression. Be a real function. I think real function, not related, it should have been real function. Then we have to find fx equal to 5 as real, 2 real roots, and so on. Let us see how this can be done. Here this expression, if we check, it comes out to be fx equal to under root of x minus 1. This is as it is. This one you can check, it is actually under root of x minus 1 minus 5 whole square inside, and then you have to place under root on it. You can check, whole square of this will be x minus 1 plus 25, so it will be x plus 24 minus 10 into root x minus 1. So we will be writing this as mod of this thing. So it will be equal to under root of x minus 1 plus mod of under root x minus 1 minus 5. Okay, now because this is mod, we can open it in two ways, either same as it is or 5 minus under root x minus 1. You can check, my domain is from 1 to 50. This thing will be initially negative. If you put x is equal to 1, you get minus 5. So it should be opened with 5 minus. So what I can say, it should be x minus 1 plus 5 minus under root x minus 1. And that will be when, till the time when x minus 1 under root is less than 5, which will be true when x is from 1 to 26. 26 close bracket, and 1 also I think close bracket. After that, when x becomes bigger than 26, I think it will be under root of x minus 1 plus, this will become positive, so we will write it as under root x minus 1 minus 5, and that is for x belongs to 26 comma 50. Okay, let us write this here. So my function has now become, the function has now become just 5 here for x belongs to 1 to 26, and after that it will be 2 under root x minus 1 minus 5 when x belongs to 26 comma 50. Okay, this is how the function is. Now you can check whether fx is equal to 5 is exactly 2 real root. I think for all x that is between 1 to 26, I think it is 5, so exactly 2 real root is not possible. Fx is 1, 1, I think that is also not true, because for x from 1 to 26 we have constant value 5. Now fx equal to 9 has 2 real roots. Here we are having 5 roots, whereas this portion seems to be increasing. In fact, if you draw the graph, okay, this is my x-axis, this is 1 here, this is 26 here, and this is 50 here. Okay, so till 1 to 26 it's a constant graph. After 26, 1 minute, yeah, after 126 it will be something like this. okay, which will be increasing actually. So, and the last point, that is 50, if you put 50 here, so it becomes 7 into 2, 14, 14 minus 5, 9. So it will be 50 comma 9. So the maximum possible value is 9, and that is true, that is possible at 50. But at 9, when fx is 9, we are not having two real roots, we are having only one root, so this option is also wrong. Now between 26 to 50, the value here was 5. So 5 to 9, this graph is increasing, you know, monotonically, you can say. So fx is equal to 7 will have some root, exactly one root actually in between. So this option D is correct. D option is correct. Now moving to the next question, that is question number 4. The number of integral values of A for which all extrema means where maxima or minima occurs, that is value of x where local maxima or minima of function lie in the interval 0, 5. Okay, here I think it is clearly written that we are talking about the values of x where maxima or minima will occur. It is not the value at those maxima or minima, it is in terms of x and lie in the interval 0, 5. Then you have to find number of integral values of A. Okay, now whenever we are talking about maxima minima, I think we need to do the differentiation. In this case, if you see f dash x will be equal to 3x square minus 6ax plus 3 into a square minus 4. We can take 3 common, so it will be x square minus 2ax plus a square minus 4 equal to 0. If we do, we will get points of maxima and minima. Here this is a perfect square, which is perfect square of x minus a whole square equal to 4. So from this we get x equal to either 2 plus a or minus 2 plus a, minus 2 plus a. So these are the points of maxima or minima. Combinedly you can say points of extrema, which is what they are asking. Number of integral values of A for which all extrema lies in the interval 0, 5. Now we want the values of these x. 2 plus a will be definitely lying on the right hand side on the number line, and minus 2 plus a will be lying on the left hand side, and we want this to lie in the interval 0 to 5. So 0 and 5 should be situated like this. In fact, we are given open interval 0, 5, so 0 cannot be equal to minus 2 plus a, likewise 5 also cannot be equal to 2 plus a. So what we want a minus 2 to be greater than 0 and a plus 2 to be less than 5. So from this we get a to be from, I think, 2 to 3, 2 to 3 open bracket. Now in 2 to 3 how many integral values are there? I think there is no value, so answer of this question will be C. Simple question, you just have to do the differentiation. Okay, moving to the next question, that is 5. Yeah, answer was C. From the point 1 comma minus 1, tangents are drawn to the curve represented parametrically as x is equal to 2t and y equal to t square. Distance between the point of contact is. This is, I think, parabola. You can see if you eliminate t, it will be parabola, though it is not required, but still just to make a diagram, I will make a right diagram only, that's the parabola. Okay, and it will be right opening parabola, upward opening parabola, you can check. And from point 1 comma minus 1, we are going to draw tangents, one tangent here and one tangent here. My question is, my question here is that we have to find the distance between these 2 points. Okay, it is kind of length of chord of contact they are asking. Okay, now to do this question, what we can do, this point is 1 comma minus 1. Okay, we can say these points are T1 and T2. Okay, which can be represented from this 2t comma t square. For one it will be T1, for other point it will be T2. But from the to start this question, I will take just 2t comma t square only. Okay, and how I am going to approach, please see. What I was saying, that for T1 and for T2 both, I will take single value t only, and that t will have 2 solutions, one as T1, one as T2. So let's say it was t here, it could have been here also. Now we will approach this question in that way, that the length, the slope of tangent joining this point to 1 comma minus 1, and this point is how much? X coordinate is 2t, y coordinate is t square. Y coordinate is t square. So slope of line joining this A, let's say, and this is P, let's say, and this is Q, let us say. So slope of AP will be equal to tangent at P. Okay, now slope of AP would be t square minus 1 upon 2t minus 1, and that should be equal to slope of tangent at P means derivative. So we can do the parametric differentiation dy upon dt, that is 2t in the numerator, upon dx upon dt, that is 2 here. So that is what we are getting, t here, and that will be t square plus 1 equal to, this t will be multiplied here, so 2t square minus t. So we get a quadratic which is t square minus t minus 1 equal to 0. Now I was talking about this in the beginning, that though I am taking this point as t, but this t can be here or here also, which means this quadratic, which is supposed to have 2 roots, and these 2 roots will actually be the parameter of these 2 points P and Q. So here you can see the sum of roots, you can find t1 plus t2 is 1. Product of roots also you can find t1 t2 as minus 1. Okay, now what we are looking for, we are looking for the distance PQ, which will be equal to under root of, I think 2 can be taken common, so it will be come out as 4, and t1 square minus t2 square. No, 1 minute. T1 minus, actually I am using the distance formula. So 2t1 minus 2t2 whole square, 4 will be outside, t1 minus t2 will be inside, whole square here, plus t1 square minus t2 square whole square, that is for y coordinate. Now you can see from this entire thing we can take t1 minus t2 outside, I think it will come out with mod sign, and inside it will be 4 plus t1 plus t2 whole square. Okay, now we need t1 minus t2. I think there is a result for difference of roots also, or you can use sum of roots, product of roots, and you can find t1 minus t2 will be equal to under root of this square minus 4 times this thing. I think it will come out to be root 5, you can check. Okay, now we know, yeah, let me do it here. We know this is root 5, and this is 4 plus t1 plus t2 is 1, so this is also root 5, so this distance comes out to be 5. So answer for this question will be B. Okay, yeah, B. Moving to the next question, that is question number 6. We are given fx equal to 1 plus x square upon 1 plus x for x belongs to 0, 3. We have to find the sum of absolute maximum and minimum value of fx. Okay, now to do this question we can use maximum minima, okay, or maybe AMGM also. Let's do it through that AOD, that is maximum minimum. So I will first do the differentiation. So it will be f dash x equal to, in the numerator it will be 2x into 1 plus x minus 1 plus x square into 1, the differentiation of denominator 1, and in the denominator it is 1 plus x whole square. So this becomes equal to, I think, x square here, 2x square minus x square plus 2x minus 1 in the numerator and x plus 1 in the denominator. Okay, if we equate this to 0, we will be getting x to be equal to minus b plus or minus root over b square, that is 8, b square, that is 4, 4 minus 4, that will become 8 here, upon 2. Okay, if we solve it, I think we will be getting this as minus 1. If we solve this, we get this to be equal to minus 1 plus root 2, because minus 1 minus root 2 will not be in this interval. 2 will cancel it, and root 8 is 2 root 2, so 2 is also cancelled. Okay, now also if you check the change of sign of first derivative, because it's a quadratic here, so root 2 minus 1 critical point here, and another would have been minus 1 minus root 2. So you can check plus sign here, minus sign here. So at this point, this graph will be having point of minima. Okay, and between 0 and 3, there is no other point of extrema. That means at this root 2 minus 1, we will get one point of minima. So this graph should look like this only. May not be exactly parabola, but it will be something like this only, where minimum will occur at root 2 minus 1, root 2 minus 1. Okay, and at 0 value will be 1 here, at 3 if you put, it will be 5 by 2 here. Okay, at root 2 minus 1, if I put in this expression, let's do this calculation here. So it will become 1 plus x square will be 3 minus 2 root 2 whole divided by, I think, just root 2 here. Okay, so this becomes, if you divide by root 2, 2 root 2 minus 2. So that is the minimum value here. 2 root 2 minus 2 will be here. Okay, now they are asking the sum of absolute minimum, that is this, and absolute maximum. For that, I think we should compare 1 and 5 by 2. So if we compare these two, the sum will become, equal to 5 by 2 plus 2 root 2 minus 2. So it will become equal to 2 root 2 plus 1 by 2. Okay, so the answer for this question will be C. Okay, I think easy question, not very difficult. You could have done this question with the help of AMGM also. I'll tell you how you can do it. I'll just tell you few steps, and after that you will be able to do it. Yeah, answer is C. See, this expression can be written as 1 plus x whole square minus 2x upon 1 plus x. Okay, and further we can write it as 1 plus x minus this x, I will write it as 2x plus 1 minus 2 upon 1 plus x. Okay, so here it will become 1 plus x plus 2 upon 1 plus x, okay, minus 2. And now we can apply AMGM on this, and you can check for x belongs to 0 to 3, this entire thing is positive, so AMGM can be applied, and it will be greater than or equal to 2 root 2. So you get the minimum value very easily, and this minimum 2 root 2 will happen when these two numbers are same. That means 1 plus x equal to 2 upon 1 plus x, which will give you the value of x also, that is root 2 minus 1. So we can do this question with the help of AMGM also. Now moving to the next question, that is question number 7. We are given fx is equal to xn cos 1 by x plus sine 1 by x, and equal to 0 for x not equal to 0, and for not equal to 0, the first thing. Now we have to tell for n equal to 2 whether fx is both continuous and differentiable, continuous but not differentiable. For n is equal to 1, both continuous and differentiable. For n is equal to 1, neither continuous nor differentiable. Let's see. Now at least n is 1 or 2, at least n is 1 here. So assuming n is at least 1, let's try to check the continuity. So for that I need to find the limit x approaches to 0. Okay, and the limit obviously will be found from the first expression. Now because n is either 1 or 2, so we can say this x raised to the power n will be approaching to 0, whereas this bracket cos of 1 by x plus sine of 1 by x, which will be actually oscillating values. This can go from minus root 2 to plus root 2, minimum value, maximum value. As your x approaches to 0, your 1 by x angle will be tending to infinite. So you cannot say that what will be the precise value for this expression, but it will definitely be lying between these two things. Okay, but if it is multiplied with x power n, okay, and the value between minus root 2 to plus root 2, when it is multiplied with this, will be equal to 0. So this means limit is coming out to be 0. Okay, for limit is coming out to be 0, and x equal to 0, on x is equal to 0, the value is also 0. That means function is continuous. So the case that neither continuous nor differentiable should be wrong. Okay, now let's check when it will be differentiable. Now if it is continuous, okay, then we have to check at x is equal to 0 the differentiability. So to do that, what we can do, we can write x approaches to 0, fx minus f0, which is 0 only, upon x. Okay, now this way if we do, let me write this f0 first so that you don't get confused. f0 is 0, so I will not write this term once again. So here limit x approaches to 0, fx, I'll take that expression and divided by x will give you x raised to the power n minus 1 into that expression. Now I think it should be very clear, if n becomes equal to 1, then it will not be there, it will be just 1 here, you can say x will cancel this x above, and this thing will be actually oscillating between minus root 2 to root 2. So in that case, if n is 1, this limit will not exist. That means for n is equal to 1, it will be continuous, but it will not be differentiable. So I think this option is also wrong. But for n is equal to 2, this will be x, which will be tending to 0, whereas it is oscillating between minus root 2 to root 2. So this entire thing will become, this limit become equal to 0. So it will be differentiable if n is equal to 2. So for n is equal to 2, we get both continuous and differentiable. That's how this question is done. Moving to the next question. Answer was A. Yeah. Now question number 8. A relation R on the set of M of 3 into 3 matrices with real entries such that for any A comma B belongs to M. Yeah, I think there should be comma. A comma B belongs to R if and only if AB transpose is equal to A transpose B transpose. Let's see how this we can do. And they are asking only symmetric and reflexive. They are not asking for transitive. Let's see how this can be done. Now, if we want to check reflexive, I'll check whether A is related to A or not. Okay, A will be related to A if, as per this relation, that A into A transpose is equal to A transpose A transpose. I think that's true, because if you use the property of transpose where order gets reversed, we can say we will write first transpose of this A and then transpose of the other A. But that is same thing, A transpose into A transpose, which is actually true. So it has to be reflexive. So it is reflexive. Now coming to symmetric. For symmetric, we assume that AB belongs to R. Okay, that means AB transpose will be equal to A transpose B transpose. But as we know from the property that this is also equal to B transpose A transpose, which means if A is related to B, then B transpose A transpose will be equal to A transpose B transpose. Okay, now to check whether BA also belongs to R or not, I think we need to have B into A transpose equal to B transpose A transpose. That is what we need. But from the property, I think it is first A transpose into B transpose, that ordered reversal property, A transpose into B transpose. But we have already seen this, that if AB belongs to R, then this A transpose B transpose or B transpose A transpose, they both are same. So that these two are equal, and hence we can say that if AB belongs to R, then BA also belongs to R. So it will be both reflexive and symmetric, reflexive and symmetric both. So answer will be C. Okay, moving to the next question. For x between -1 to 0, we are given two statements. First statement is 2 sine inverse x is equal to cos inverse 1 minus 2x square, and statement B is 2 cos inverse x equal to 2 pi plus sine inverse 2x under root 1 minus x square. We have to find which option is correct and which option is not correct. Okay, now let's do one by one. For statement A, I'll check first and I'll go with RHS. And let's see if it becomes equal to LHS or not. So to do that, I will take x as sine theta, so that this expression will give you cos 2 theta formula. Now because x is from -1 to 0 and x is equal to sine theta, okay, in such substitution we always take principal range. Principal range means it will be from minus pi by 2 to 0. It will be from minus pi by 2 to 0. Now if you put it here, my RHS will become equal to minus cos inverse cos 2 theta. Okay, now if theta belongs to this, then 2 theta will belongs to minus pi comma 0. But this minus pi comma 0 is not the principal range of cos inverse function. Principal range is from 0 to pi. So to make it 0 to pi, I think we can write it as minus of minus 2 theta here. So this RHS will become equal to 2 theta. I think to do such questions, you might have done the graphs like this. To draw the graph of y equal to cos inverse cos x, what we do for x being in principal range, it is always x, and after that it is zigzag shape graph, and on this side also. So here my x or theta here, or 2 theta here actually, was from minus pi to 0, and this side the graph is actually of y equal to minus x, y equal to minus x. So that's why this 2 theta, cos inverse cos 2 theta will become minus 2 theta, that is 2 theta, and we took theta as sine inverse x, so I think it is becoming equal to LHS. So my statement A is correct. Now let's see if statement B is also correct or not. Okay, yeah, I think I can use it here. For statement B, yeah, this is the statement B. Let's take it from here. Again, I'll take RHS first, and I will put x equal to, because I need it in terms of cos inverse, so x as cos theta. So if it is cos theta, my RHS for B statement will be equal to 2 pi plus sine inverse sine 2 theta. Sine inverse sine 2 theta, you can check, because it is 2x into root 1 minus x square. X is cos theta, so root 1 minus x square will be sine theta. When I am saying x is cos theta and x is between minus 1 to 0, that means my theta will be in second quadrant, because for cos theta principal domain is 0 to pi. So here it will be from pi by 2 to pi, where pi by 2 it will be open bracket, at pi it will be closed bracket. Okay, now if theta is this, then your 2 theta will be pi comma 2 pi, pi comma 2 pi. Okay, now the graph I was discussing for cos inverse, similar graph is there for sine also. And how sine inverse graph is there, let me draw it here. If I have to draw graph of y equal to sine inverse sine x, I think it is minus pi by 2 to pi by 2, it is y equal to x. After that it is zigzag shape graph like this, pi by 2 to 3 pi by 2, pi by 2 to 3 pi by 2, it is, I think, pi minus x, and from 3 pi by 2 to 5 pi by 2, it is, I think, x minus 2 pi. Okay, our interval is from pi to 2 pi. I think this will be the point pi, this will be the point 2 pi. Okay, so you can see you cannot have sine inverse sine 2 theta given by single formula. It will be two things, either pi minus 2 theta or it will be 2 theta minus 2 pi. Okay, so let me write it here. I think it will become two things. First will be x minus 2 theta, sorry, pi minus 2 theta. This is pi here. This is pi minus x. So for the first interval, for this pi to 3 pi by 2, because my 2 theta is from pi to 2 pi, so for 2 theta to be from pi to 3 pi by 2, it will be pi minus x. If I put it here, you get 3 pi minus 2 theta. And for the other part, 2 pi will get cancelled and we will be getting 2 theta. And we put x as cos theta, so this other part, second interval, that is from 3 pi by 2 to 2 pi, it will be 2 cos inverse x, but for first part it will not be 2 cos inverse x. So you can check that statement A is correct, but statement B is not correct. I hope you are getting, by after putting this cos theta, we are getting two definitions for this RHS. One, 3 pi minus 2 cos inverse x, and another is 2 cos inverse x. So this is not entirely equal to 2 cos inverse x for all x belongs to 0 to minus 1. Okay, so the answer for that has to be only A is correct. Other options for B is correct. I think that is wrong. Both are correct, both are incorrect, are neither A nor B are correct. I think this is also wrong. So moving to the question number 10, we are given number of points of non-differentiability of function minus infinity to 2 pi, open bracket 2r. Okay, now let's see how this can be done. I think better would be that we make the graph of this type of questions. So first part is tan inverse mod 10x, that is from 0 to 2 pi. Once again, we will require the graph which I was discussing for sine, cos. So for tan inverse mod 10x, first of all, please understand that tan inverse mod 10x, whenever 10x will be negative, mod will first make it positive, then tan inverse of mod 10x will always be lying from 0 to pi by 2. Okay, if it is negative, then mod will make it positive. Tan inverse of this positive will always be 0 to pi by 2, because that is the principal domain or principal range of tan inverse. Okay, so in that way, I think we can write this also as mod outside tan inverse 10x, because that is also, this mod is also doing the same thing. Suppose your 10x was negative, then tan inverse 10x will be an angle that is in the interval minus pi by 2 to 0, because for principal domain, principal range, if I talk about, it is from minus pi by 2 to pi by 2. So it will give you minus pi by 2 to 0, and if you put mod outside, it will again make it in the range 0 to pi by 2. So if you put mod here or you put mod like this, it's the same thing. I hope that is clear. Now I'll make graph of this tan inverse 10x, that is what I think minus pi by 2, and we need 0 to 2 pi. Okay, so from minus pi by 2 to pi by 2, it was like this, then pi by 2 to 3 pi by 2, then 3 pi by 2 to 5 pi by 2, like this. The graph of tan inverse 10x is like this. Y equal to tan inverse 10x. If we draw the graph of this, it is like this: minus pi by 2 to pi by 2, it is y is equal to x. Then for pi by 2 to 3 pi by 2, the graph is y equal to x minus pi, and then y equal to x minus 2 pi, and so on. At all odd multiple of pi by 2, it is not defined, because we cannot define 10x there. Okay, now this is the graph of tan inverse 10x, but we want mod of this thing. Okay, now if I have to draw the graph of mod of this thing, what I will do, okay, I'll make the graph here, or maybe I'll use this space, little crunch of space, maybe, yeah, I'll use here. Can I write here? Let me see. Yeah, then it's perfectly fine. So here we can see from 0 to pi by 2, the graph will be like this. And then after that, because mod is there, so the portion that is below x-axis will move like this till pi. Similarly, pi to pi by 2, it will be pi to 3 pi by 2, it will be like this. And then after 3 pi by 2 to 2 pi, it will be like this. But in the question, you can see 2 pi, we are having open bracket, so it will be not defined, or it should be open circle, open point, you can say, at 2 pi. Now at x is equal to pi by 2 or 3 pi by 2 also, they have defined as pi. Whereas from this formula, if you check y is equal to x, at pi by 2, this limit would have been only pi by 2. So pi will be lying somewhere here above it. And before 0, before x equal to 0, the graph is given by mod of x square plus 2x. If you draw the graph of x square plus 2x, I think it's a parabola whose roots are, I think, minus 2 and 0. If it is mod outside, I think we will be, we'll be converting, you can say, or we'll be reflecting the portion below x-axis towards positive side. So it will be the graph of mod x square plus 2x. So if I make this graph here, I think it will look like this. Please see. Okay, this will also be a corner point here. So now you can count the point of non-differentiability. I think that is 1, that is 2. This is also a point of non-differentiability because of discontinuity. And this is also point of differentiability because of discontinuity, and this is also 1 point. I think 4 would have been this, and this would be 5th point. This will be the 5th point. So total 5 points of non-differentiabilities are there. So answer for that question will be C. Okay. Now moving to the next question, that is question number 11. Okay. Here we are given a functional equation that f of x plus y upon 3 is 2 plus fx plus fy upon 3 for all real x and y, and f dash 2 is 3. Then we have to find f dash 4 plus f4 equal to, where f dash x is d upon dx of fx. Let's see how this question can be done. First of all, if I put x is equal to 0 and y equal to 0, I think this relation give you f0 here equal to 2 plus 2 times f0 upon 3. Cross multiply here, I think we will get f0 to be equal to 2. That is one value we are getting for f0. Okay, now f dash 2 is equal to 3 we are given. Okay, if I try to find f dash 2, please see, it should be equal to f of 2 plus h minus f of 2 upon h, and limit h approaches to 0. Limit h approaches to 0 is obvious. Okay. Now to do this question further, what we can do, we can use this definition here. I will write it like limit h approaches to 0. Okay. And I will write 2 plus h as f of 6 plus 3h upon 3. Okay, minus f of this 2 also I will write it as 6 plus 0 upon 3 whole divided by h. Okay, now because we know the expression, the expression for f of x plus y by 3. So here x is 6, y is 3h. Here x is 6, y is 0. If you put them, you will be getting, I think, few terms cancelled. H approaches to 0. I think f6 will be cancelled. Okay, 2 will be cancelled. So we will be left with f of 3h here minus f of 3h upon 3 here minus f0 upon 3 here whole divided by h. Okay, f0 I think was not required here. Maybe I can do it directly. Limit h approaches to 0, f of 3h minus f of 0 whole divided by 3h. Now this expression is actually the expression of derivative of function at 0, f dash 0. Okay, now you can see if it was not 2, if it was x also, okay, if it was x also, so at everywhere you can see this x would this would have been 3x, this would have been 3x. So we will be getting same expression here. That means if we do similar calculation, we will find that derivative at x or derivative at 0 or derivative at any x will be same, and that is possible only if it's a linear function and the f dash x value is equal to 3. Also we are given f we have found f0 equal to 2. So linear function, so we are having linear function and we are having f dash 0 equal to 3. If we combine this, I think we will be getting fx to be equal to 3x plus 2. Value at 0 is 2. Yeah. Now we are supposed to find f dash 4. I think f dash 4 is nothing but 3. But also we need to find f4. So f dash 4 is 3. And f4 will be 4 into 3, 12 plus 2, 14. So it will be 17. So answer for this question will be 17. Okay. Moving to the next question, that is question number 12. So here we are given that fx is equal to 1 minus x cube, then least integral value of x satisfying the inequality 1 minus fx minus f cube x greater than 1 plus x cube. Dear all, please listen carefully. Bit tricky question, I'll say. And here you can see this fx or f dash x is equal to minus 1 minus 3x square. That will be negative always. So my function fx is strictly decreasing. Also, if you look at this expression on the left hand side, we can write it as f of fx. that is greater than, and this expression on the right hand side is actually f of minus x, because if you put minus x in place of x, you get same thing. Now because fx is decreasing and f of fx is greater than f of minus x, so I think we can remove one f from here and one f from here. We will be getting fx to be less than minus x. Okay, whereas my fx was 1 minus x cube, okay, and that is less than minus x. Now this minus x will get cancelled and we get x cube to be greater than 1, which means for x greater than 1, this inequation will hold. But they are asking the least integral value of x. So if x is greater than 1, so the least integral value has to be 2 only. Okay, so that's how this question is done. Moving to the next question, that is 13. Okay, in this question we are asked to find the limit. Please see how this question can be done. We are given x approaches to 0, e minus 1 plus x power 1 upon x, and x is approaching to 0. So dear all, you might be knowing this thing already, that as limit x approaches to 0, 1 plus x, this base will tend to 1 and this will tend to infinity, so it's a 1 power infinity form. So we do this kind of question as e raised to the power x into 1 by x, it comes out to be e as x approaches to 0. So you can see that in this numerator, this is also tending to e, it is not equal to e, and this is also e, so it becomes 0, and denominator also it is becoming 0, and here also it is becoming 0. So let's see how this can be done. Now to do this question, what I will do, this portion I will write it as limit x approaches to 0, e minus this I will write it as e raised to the power ln of 1 plus x raised to the power 1 by x. Whereas in the denominator, e raised to the power ex minus 1, if I divide by e power x, or not e power x, yeah, e into x, sorry, e into x, so I'll multiply by e into x here as well. Okay, this limit will become 1, and this same thing I'll do for other parts also, like sine square 2x, that means sine 2x whole square, I will multiply and divide by 2x here, so here it will become 4x square, and upon it is x into 10x. So 1x will get cancelled and x upon 10x is also 1. So what are we left with after this calculation here is limit x approaches to 0. In the denominator that will be ex only, because that will become 1. This will become 1, and here we will be having 4 only. Okay, now what I am going to do, from this numerator I will take e common, rather minus e common. So what it will become, e raised to the power, I think we can multiply 1 by x with log outside. There is a property 1 by x ln 1 plus x minus 1 minus 1. What I have done in the numerator, I have taken e common, so there will be minus 1 in the power of this e, and this e will be outside, and you will have minus 1 here, and upon we were having only e, and 1x was also there. Yeah, that's it. Okay, now this e will be cancelled and there is a minus sign also, please remember, and there is a 4 also here. Now to do this question, let me again use the same thing. Yeah, I'll make this small and I'll do it here. Yeah. Now to do this question, what I'll do here is, yeah, limit x approaches to 0, okay, and minus 4e I can write outside, 4 and minus e outside, and for that once again I will use that expression, that standard result, e raised to the power x, this result I am talking about, e power x minus 1 upon x equal to 1 when x tending to 0, which we have already used when we wrote this e raised to the power e into x minus 1 upon ex as 1. Okay, so how we will do it, please understand this expression here, 1 upon x ln 1 plus x minus 1 is actually tending to 0. You can check, as that's a standard limit, ln 1 plus x upon x tends to 1, so 1 minus 1 will tend to 0. So what I will do, I'll again this e power 1 by x ln 1 plus x minus 1 minus 1. I will divide by 1 by x ln 1 plus x minus 1 by this, and then I will multiply the same thing here also. So 1 by x ln 1 plus x minus 1. Okay, and there was one extra x also, I will put it here. Now after this, I think this bracket will again can be written as 1, because these two things are same tending to 0. Using this standard result, we can write it as 1. Okay, so what is my next step? Limit x approaches to 0 minus 4e. Okay, here I will like to use expansion, or maybe you can use LH also. Let's use LH. ln 1 plus x minus x after LCM upon x square. You can check it is a 0 upon 0 form. As you put x is equal to 0, 0 upon 0 form. If we use LH, so what will we get? X approaches to 0 minus 4e into differentiation of ln will be 1 upon 1 plus x minus 1 whole divided by 2x. If you take LCM in the numerator, it will be minus x. Okay, so minus x will cancel this x minus times, but that minus sign is outside also, so you can put it as 4e, and I think it will be 4e upon 1 plus x. So here it will be minus 1. I think 1 upon x we are getting. Yeah, only 1 upon x, and this 2 was also there. Yeah, 2 was also there. As x approaching to 0, so it will become 2e. Okay, I think I have done a mistake here, that e was cancelled, but I was still carrying this e here. I don't know why. So let me delete this e. Let me delete this e, this e, this e, this e. So answer will be 2 for this question. Let's see. Yeah, answer is 2 for this question. Bit tricky question because of this taking log in a special manner, where you have to write this 1 plus x raised to the power 1 by x as e raised to the power something. So that is bit tricky portion, and here you could have done by expansion also or by LH also. Okay, so moving to the next question, that is 14, I think second last question. Here we are given that Rolle's theorem if Rolle's theorem is applicable to fx on minus 2 to 2, then we have to find the value of 18 c minus q upon p. Let's see how this can be done. Here we are given fx in two parts. For less than or equal to 1, it's a quadratic. For x greater than 1, it's a p upon x plus q. Okay, now if Rolle's theorem is to be applicable, I think we need to have value at minus 2 and 2 to be same. That means if I put minus 2 in this first thing, it will be 4a minus 2b plus c, and if I put 2 in the second definition, it will be p upon 2 plus q. That is one equation. Okay, for Rolle's theorem to be applicable, it should be continuous at 1, because at other points they will be definitely continuous. For x equal to 1, the left limit and value will come from this quadratic, that is a plus b plus c, and right limit will come from p plus q, that is equation 2. Now one more thing, differentiability at 1. As this quadratic is always differentiable, p upon x plus q will also be differentiable for x greater than 1. So only point of concern is x is equal to 1. So left hand derivative will be by differentiating this, that will give you 2a plus b after putting 1 also, and equal to, this will become minus p upon x square. Putting x is equal to 1 will give you minus p only, and that's it. Yeah. Okay, so these are the three equations. Using these three equations, we have to find c minus q upon p. 18 is also multiplied. C minus q upon p. That means I want to eliminate a and b. I want to eliminate a and b. Please understand this thing. Okay, how a and b can be eliminated? You can find the values of a, c, q, p in terms of a and b. Maybe that can be one idea, but I'll tell you some different way. Please see how. See, this question is correct. Then I think if we try to eliminate a and b from these three equations directly, I think we should be able to get this required result. That is my belief. Let's see how this can be done. What I'm going to do, I'll be multiplying this by x and this by y, and I will try to make terms of a, terms of b to be same as which are there in 3. Okay, so what I'm trying to say that if I multiply first equation by x, so my coefficient of a will become 4x. If I multiply second equation by y, my coefficient of a will become y. Now if I want terms of a to be same as given in 3, so it will become equal to 3. And likewise for b, it will be minus 2x plus y is equal to 1. If you simplify them, I think x comes out to be 1 by 6. And if I put x there, y will be equal to 4 by 3. 1 plus 1 by 3 is 4 by 3, that's correct. Now let's assume x is 1 by 6, y is 4 by 3. So I multiply 1 by 6, 2 by 4 by 3 and subtract 3. Obviously a and b term will cancel because I started with this only. So a and b term will cancel. I will have only c, p and q terms. So on the left hand side, my c will be actually 1 by 6 plus 4 by 3. 1 by 6 plus 4 by 3. So it will be 1 plus 8, 9. 1 plus 8 is 9, 9 by 6. 9 by 6. 9 by 3, 6 or 3 by 2 c. What I have done? Let me write it once again. I multiplied equation 1 with I think 1 by 6. I multiplied 2 with 4 by 3 and then I subtracted equation number 3. So my a, b terms are getting cancelled. C will be just 1 by 6 plus 4 by 3, that is 1 plus 8, 9 by 6, that is 3 by 2. And on the right hand side, the term of p, let's see, it will be 1 by 12 plus 4 by 3 minus plus 1 into p. Okay, and for this 1, I think calculation is very similar to c only because here it is c, here it is q, here it is c, here it is a q. So they will be having same things. So that will be 3 by 2q. Okay, now I need to know c minus q. So I'll bring this here. So 3 by 2 common, c minus q divided by p also we need. So it will become equal to the sum of this thing. That means if I take LCM 12, it will be 1 plus 16 plus 12. So that becomes I think 29 upon 12. Okay, so 3 by 2 c minus q into p is equal to this thing, but we are asked to find 18 here. So that means I need to multiply by what? I think to get here 18 means it will be 12. I think I have to multiply 12 here. I think then we are done. Answer will be 29. Let me write it here. So 18 into c minus q upon p. For that I multiplied by 12 both sides. 12 into 3 by 2 is 18. 12 into 3, 36 by 2, 18. And the right hand side it will become 29. So answer for this question should be 29. Bit tricky question for this portion only. Otherwise this was easy. I think you will not find it difficult. Okay, moving to the last question. Here we are given S denote the set of all distinct values of lambda for which the system of equation is inconsistent. Inconsistent means there should not be any solution. Okay, no solution or infinite solutions occur when the value of determinant is 0. Okay, and which determinant I am talking about? The first row will be lambda 1 1, second will be 1 lambda 1, and last will be 1 1 lambda equal to 0. Okay, you can open it and you will be able to see it will be lambda plus 2 whole square into lambda minus 1 equal to 0. Sorry, whole square here and power 1 here. Okay, you can check by factor theorem also that if you put lambda equal to 1, your entire determinant is becoming 1 1 1 1 1 1. Means there are 3 rows which are identical. So lambda minus 1 will be a repeated root. And also you can check if you add 3 columns, you get lambda plus 2, lambda plus 2, lambda 2 common. So lambda plus 2 should be one factor. And this cannot be of degree more than 3. So I think we are done with all the factors. So either lambda will be equal to minus 2 or it will be equal to 1. So there are 2 values. Now I think it is very much clearly seen that if I put lambda equal to 1 here, so it will be x1 plus x2 plus x3 everywhere on the left hand side, but on the right hand side it is 1 1 minus 2. That means if x1 plus x2 plus x3 is 1, then it cannot be minus 2. So for 1 definitely it should be inconsistent. There will be no solution for 1. It is like, 2 equations you may represent them by a 3D plane. So first two are identical plane, but third is a parallel plane to first two, you can say. So if they are parallel planes, they can never intersect each other, so there will be no solution for this lambda equal to 1 for sure. Now moving to this value of lambda equal to -2, for that maybe we can find the values of dx, dy, dz, that will give you the answer. Okay, or maybe what you can do, you can try to see whether if I try to find the solution for lambda equal to -2, okay, -2 x1 plus x2 plus x3 is equal to 1, and here it is x1 minus 2 x2 plus x3 equal to 1. Okay, now if I add these two, what we will be getting, it is minus x1 minus x2 plus 2x3 is equal to 2. You can check, this is nothing but third equation only with multiplication of -1. Minus x1 minus x2 plus 2x3 equal to -2 there. Here we are having 2. So this equation same. That means they are actually three planes, actually part of same family of planes, you can say, passing through the intersection line of the two planes, you can say. So that's how also you can say they will be having infinite solutions. Or there is another method that you find dx, Cramer's rule, you will get 0, dy you will get 0, dz also you will get 0. So from there you get all determinants are coming out to be 0, so it will have infinite solutions. Okay, so this is how this question is done. I hope you must have done better. You must have done better than your previous two exams in this paper. So answer is 1. Actually they were asking S denote the set of all distinct values. Then they are asking the sum of this sum of the values inside the set. So there is just one value 1, so sum will be 1. Okay, so this completes the solutioning of this question. Thank you so much, bacho. I'll come again with some other things. Okay, till then, bye.